just, there we go. So with that, I will go ahead and hand it off to Matthew. He's going to be our first presenter today.
All right, so let me go ahead and share my screen. And just give me a thumbs up if you can see my, okay, perfect. So yeah, thanks for having me today. My name is Matt Viverito. I'm a solution engineer at Esri. I work with state government agencies across West Virginia and then some other states in the Southeast region. I'm actually out of the Northern Virginia office right now in my house in Ashburn, Virginia. But anyway, so today I'm going to talk about the hub. I'm going to concentrate more on state governments. So let's just take a look at the agenda real quick. So I'm going to go over, I came up with some concepts or some ideas you always want to think about when you're planning a hub. And I'm going to go over those thoughts with you and strategies to designing a hub. And then I'm going to show you a couple of quick examples of what some current customers are doing right now and how they're using the hub. And they're using it in some common ways that your organization might use it in some different ways as well. But you can see how they're using it to support different initiatives. The next part of my agenda, and I'm gonna have to go pretty quick because I only have half hour. I'm gonna take a program from Connecticut, the state of Connecticut, called their Adopt a Park program that I found online. I'm actually from Connecticut. And I'm gonna show you how I took their existing program and transferred that program into a hub site and how to interact with it and the reasons why I put it into the hub. And then finally, I'll leave you with some resources to look at that Esri provides so you guys can learn more about the hub and answer any questions. All right, so let's go ahead and get started. All right, so planning a hub, typically I ask myself 3 questions when I want to create a hub site to support an initiative that my agency is doing. So the first one is the challenge, is identifying a business need. The second one is the customer. So how is your, who is your customer and how is your customer going to interact with your hub site? And then finally, the workflow. So how are you going to interact with the hub site with your customers, for example? Or even internally, are you going to leverage some tools that the platform provides your users, for example? So we'll get into that in a little bit more detail, but you can see I broke this out into even more detailed questions. And at the end of this, I can share these links out to you so you can have these to look at. These are actually what you're looking at here is a hub site that I built just to use as my instead of a PowerPoint. I like to use Hub now as a vehicle to share information. But you can see that, the first thing is the challenge. So you want to identify a problem or a business need. And then you want to ask yourself, some questions. Are there any reporting requirements? So as a state agency, do you have to report up to the federal government? Are you measuring performance metrics, for example? Do you want the community to participate? Do you want them to have access to information that the general public might not have access to, or a specific citizen might have access to? So maybe you have an organization like a volunteer group that you want them to go out and collect survey information, and you want to give them access, but you don't want the general public to access that. Do you want to do those kinds of stuff? The hub is very strong at providing that capability because you have the named user concept where you can provide community member names, basically an ArcGIS Online account to your community members. The other additional thing that the hub allows you to do is to organize and plan events. And so you can have people go into your hub site and sign up for an event. The second piece that I like to talk about is like the customer. So how you really need to understand what's the customer's needs and what's going to be their experience. So how do you want the customer to interact with your website, your hub site? Do you want to be able to provide them collaboration capabilities? So do I want them to be able to upload data or share a PDF? Do I want them to download data? Do I want customer feedback? A lot of times you want to see how you're performing, for example. maybe I'd provide an embedded survey 123 form in there. And then some just quick points about before you get started with a hub. The hard part's not actually building a hub site. It's putting the information together, putting that narrative together, you know, collecting your maps and apps, your dashboards, building that text out, that narrative, and then gathering, you know, high-res images or training videos that you might have, custom training videos, and, you know, really anything to help tell that story and putting that together into the hub. That's the hard part, is putting it to actually gather that information. Putting the hub together itself is the easy part, and I'll show you that in my demo. And then finally, you know, what's the workflow? So from your agency to the community, do you want to send information to specific members that are following your initiative? Do you want to manage the way your internal staff accesses a particular dashboard that you don't want the community members to access? And then do you want to use the hub to make it repeatable? So for example, in the state of Maryland, their DOT, they're using the hub to manage their projects across the whole state. And they're using what we have called a template in the hub, where you make one hub site for each project and you just generate that same hub site over and over again and customize it based on that specific project, for example. So they're using it to make it repeatable, but have that same look and feel for all their projects across the state. All right, so now I'm going to jump into some recent examples of how state agencies are using the hub. And two of them are from Tennessee and one's from Virginia. And Tennessee, they're smart parks. They're using this, you know, really a simple use case. And what, you know, originally what the hub was designed for was to, you know, access data. And you can see they have some information that links out to a live data set here. So as this data is being updated, this information in the statistic card here is actually being updated. But what I like about this site is what they did with their open data and how to download and access their data. And you can see that they've actually created nice images here to say, okay, this is authoritative data coming from Tennessee State Parks. I want to download the park boundary. I can select this park boundary, and now I can access it. And the hub team just updated the way you view the actual interface of the way you view and interact with the data. We've made the interface much bigger for the map, but also if you want to look at the data itself. So I have this button up here on the right-hand side. I can view the table information. And I can go in here and I can actually start filtering the data. And so they made it a lot easier to filter data. So if I wanted the park name, I could say park name, search for values. I could say Big Cypress Park, and it would do that filter for me. I can also look at some just metadata here, but I can also include license information. So if you have data that has license information, you can do that. I can also go into the full details of this data. And so I can see, you know, a lot more details about the data, a summary, some attribute information, a simple map here, and then other data sets I might be interested in. If I want to create a map really quickly, I can take this data and say, I'm ready to create a map. I can start simple. I can open in a start simple, a basic styling, drawing, and analysis map, or advanced mapping, open an ArcGIS map viewer. Or I can create a story map, for example. I can also download the data. So I can hit download, and I have options to download it on the left-hand side. So I could download it to CSV, or maybe a shapefile or a GeoJSON, for example. Okay, the next example I want to show you is what Virginia Department of Conservation and Recreation is doing. They're using this to collaborate between the state agencies and the local agencies, and actually the federal agencies, to manage their trails information. So the state of Virginia is going to take all of the county, state data, and the regional data and push that up into one single data set and manage that for the entire state to access. You can see they have some statistics as well about how much data they've collected. But what they're doing here is I want to become a data collector. So they're using Survey123 to sign up. So I can fill out my name here, my organization. So maybe I work for Fairfax County. And I could say, okay, I'm interested in being a contributor. I answer these questions. I agree to the terms and conditions, and I can sign this and I submit this. Once I submit this, I get approved. And now I can have access to the rest of this hub site. So now that I'm signed in, I can have access to this group here. And so I work for Fairfax County. I can go in here and I can actually add my data to this group here. And you'll see that I have to be signed in, but I can sign in here and go access this group. And I can upload and share data to this group here, where the DCR could actually download it and integrate it into the main data set. So it's a pretty nice way to share data through this hub site. I could also, let's say I don't really have a really good way of sharing data, but I want to add my data. So I might be a smaller organization or a smaller city. I can actually access a Trails Map app here, and I can go in here and have access to add my data to my area. So let's say I live in the city of Falls Church, which is a really small city. I can go in here and I can start editing information. So I can say, I want to start adding local trails. I can zoom in and I can start editing my local trails here and start digitizing that information in here. Now, the advantage to using the hub is that because I have this identity, I can only add my information. So we know that Matt Viverito from Fairfax is adding information into this application. And so when I go back to this application, if I actually wanted to edit the map, I could only edit the map because I've allowed, the state has allowed Matt Viverito from Fairfax to edit only the data that he owns, that he has edited. So I can't edit Loudoun County's data, but I can edit my data. So it's a really nice way to control who has access to data and how to provide that editing capability. And then finally, they're taking all the data that they're collecting and they're making a public view. So this would be, as a person interested in visiting Virginia, I was interested in finding a park where I live or information about a trail. I could do a search here, drop a point, and it would pull up some information about that area. So I don't have a big enough radius, but you can see, let's do 10 miles and see if we catch anything in there. We did, we got some trailheads here, so I can look at this. And so now it's pulling up that attribute information and I can see information about that trailhead, for example, or that actual trail. Okay, so the last one I want to show you is, this is brand new. Been working with the state of Tennessee on their LiDAR initiative. So they're using the hub to support a specific program. So let's say I'm interested in the state of Tennessee's LiDAR initiative. I can come here and learn all about their program. And so what they did here is they use this gallery tab and they can link out to additional hub pages. So these are just additional hub website pages here that I can go to and I can find out what is LiDAR. It gives you all the information about LiDAR and it links out to an introduction to LiDAR data, who benefits from the data. Here's some use cases. You can go to a map. Here's some information about DEMs, building 2D and 3D data, contour data. So they have a whole page dedicated to just what is LiDAR and how to use the data. Then they go into how are they using the data? So what kind of projects are they using it for? So they've used LiDAR data for 7 projects. They've invested this much money and they've collected that many terabytes of data. And then here's actual information about their program. You can see here they have a map. This is just an image, but it shows you where their active projects are across the state of Tennessee. And then they've got an application here of actual completed projects. So I can link out to this application, and now I can explore it and see information about completed LiDAR projects here and get all kinds of information about it as well. If we jump back to this is one of the ones I think is very valuable, where the hub is advantageous, is to show where you can share training, for example. So Tennessee's done a really good job of creating some videos. So for example, how do you use ArcGIS Pro with the LiDAR data? So I can go in here and this takes me to a YouTube video and it opens up a YouTube video. If you use QGIS, you could do that as well. So it tells you learn how to download QGIS, how to add data, and then how to use their data. And then there's some additional resources. And then finally, how do you download this data? They have another application that you can use that you open up and it shows you exactly how to download their data. All right, so those are the three use cases. We're seeing the hub being used on a variety of ways, but I wanted to point out that it's really downloading, sharing data is one example, collaboration, and then finally supporting an existing program. For the demo, which I have 12 minutes left, I'm going to go through this really quickly. I took an existing program. The Department of Energy and Environmental Protection in Connecticut has an Adopt a Park program. And this is their webpage right now. They have a really good webpage with a lot of great information, how to adopt a park, who can adopt a park. And then they also have a form that you can fill out. Let me see if I can open this in the PDF. You can fill out this form and apply. You can say, when you're interested to go in and clean an actual state park, and then there's some signature information. So I thought this would be a good example of how you could take, an existing program that you might have, very similar to what Connecticut has here, where they have a web page already, they have all these paper forms, but you can put this into a hub, and I'll show you what I did. So really, to go back to those concepts, looking at what's the challenge, how are we going to interact with it, and how am I as an agency going to use the hub? And there's really three things I want you to take from this. It's going to be used as a collaboration tool. So yes, it's a place to land, a landing page to get information, really an entry point. But it's also a place for your volunteers to actually sign up. The second piece is I'm going to provide you tools that the actually ArcGIS platform provides that you wouldn't have normal access to without having that named identity. And that tool is Quick Capture. So I can use Quick Capture. It's a really big button mobile collector application that you can go out in the field and they can collect what kind of litter that they're picking up in the field. And then finally, the program itself, I want to give access to the program at the state of Connecticut, the managers there, to monitor the program. So they want to be able to communicate with their volunteers, but they also want to take that information that they're collecting out in the field, through a Quick Capture and bring that into a dashboard and see the progress. And so this is the hub that I built to do that. And you'll see it's very similar to what I did with Virginia, or how I worked with Virginia. But this is the landing page. You come in here, you can find out about the program. I brought over the theme, their headers, their social media information. And then I added some other information, a little bit more interactive, where we actually have a map that I embedded in here. So we can look at some parks that are available for adoption. I lived in Glastonbury, which is in central Connecticut, and I could say, okay, this park here, located in Glastonbury, hasn't been adopted. Well, it hasn't been adopted, so I'm interested. So let's go ahead. So I qualify, I'm over 18. I'm gonna start filling out this information. So this is using Survey 123. It's got my email information, my phone number. I can put in all that information you saw from that form right into here, and I can do it online. Again, I can ask a question, yes, and maybe another question opens up to follow up. I can pick the park I'm interested in. So I have this pre-populated, so there's no one's writing in just, you're getting errors from people writing it in and having text problems. And then finally, I can add in the dates I'm interested in, and I can sign in at the bottom. What's interesting here is I actually included webhooks, and an email is being sent to not only the person who submitted this saying, okay, you've submitted this, you've signed up to become a volunteer, but an email has also been sent to the program, the staff at the Department of the DEP department at Connecticut. And I'm waiting for this email to come in, but it's going to come in shortly, and I'll show that to you what it looks like exactly. But once I receive that email, here it is, it just came in. Let me show that to you. This email comes in and it says, thank you for submitting your application. The next step is to create a volunteer adopt the park program account. And you can do that here. Once you're approved, another email is going to be sent by the Connecticut staff, and they'll give you access to the program portal. So let's go ahead and make an account. So if I go to this link here, and I'm going to sign out because I think I'm signed in already. This is what the user would see. They would come in here and they would say, all right, I want to sign up for an account. The hub allows you to create this account. And now I can sign in my information. I can give you my name, my email, or I could actually use social media to sign in. I'm going to use my Google account. Oh, I'm using Andrea, but I want to use Matt. Let's go back. And let's go back to here again. Sorry, guys. Let me do that again. Let's go back to this page here. Let's go back to the email. Bear with me. My wife was using my computer the other day. Don't tell anybody. Hang on. Okay, so I'm going to sign in. I'm going to go to this sign up page here, and I'm going to use my Google account. And that's Matt Viverito right there. Okay, now I've created an account. Once the account has created, on the back end, I can put Matt Viverito at Gmail and provide him into a different group on the hub or a different team on the hub, which provides them access to more information. So I can provide them access to this volunteer program portal. So once I've approved them, if I didn't have a named user account and I wasn't approved, I could not sign into this. So if a citizen came off the street, tried to select this link here, if they could even find it, they would ask to sign in, and they wouldn't have access to it. But since I have access to it, I'm ready to go in, and now I can adopt the park. What can I do here? Gives you some good information about what you can bring, how do I report, and a training video. And then finally, I have this QR code, and this is giving me access to quick capture. So I take my mobile device, I scan this on here really quickly, and it will load the quick capture project onto my mobile device. Because I have a named user account, I can download quick capture on my mobile device, and I can start using that application. And then as I'm going out in the field collecting that information is going to be driven to a dashboard. I could also include other events. So maybe I have a spring invasive plant cleanup event coming up shortly. And, obviously these people are interested because they want to clean up the state parks. Maybe they want to, attend this event. They can say I'm attending because they have a named user account. I can sign up. I can get information about the event and directions to the event. But let's go back to the main page. So if I go back to the home page, and let's say I'm signed in as an admin of, I'm actual staff member of Connecticut. And now when I go to this home page here, this new section opened up. It looks very similar to what you saw the public would see, but this section has now been exposed. And this section shows me the dashboard of what everybody's collecting out in the field. Now, if I was signed up using my my Gmail account, the Adopta program, I couldn't see this dashboard. Only people that have access, the Connecticut staff members, can actually see this. Even though they're still accessing the same URL, the same hub site, because I have that unique identity, I can see this. And I can see actually at specific parks, what they're collecting out in the field. And this information is all being collected through quick capture. And then I can also look at the data too. So as I showed you before, I can go here and I can look at documents. So maybe I have some documents that are associated with the program that I want my staff to read, or specific data that I want them to access and locate. They can do that. And then they can download that information. So I know I got 3 minutes left. That was really quick. At the user conference, I am going in more detail about how I set this up and showing you the actual quick capture steps. But I thought this was a good overview just to quickly get your feet wet on you know, the advantages of using the hub, and really wanted to drive home the named user and how that identity controls different access and how you can use that to collaborate, whether it's internally, externally with other people. And then finally, let's take a look at some resources. And let me pop this up real quick. We have some websites that you guys can go to. There's the product page. The GeoNet community is a really great resource. If you have questions about the hub or other people that have questions, you can go to this GeoNet community and find answers. A lot of people from Esri's, the hub team actually respond to these. There's Learn Lessons. So we have some Learn Lessons that teach you how to build hubs. There are a lot of demos, YouTube videos, and some example galleries to give you some inspiration. And then of course, some blogs and social media is a great way to keep up with updates. So thank you for your time. I'm giving you 2 minutes back to give the next person time to talk. I don't know if you guys had any questions. I didn't get to check my chat here, but thanks for the time. I appreciate it.
So much, Matt.
Thanks, Matt.
So up next, you'll just have to stop the screen share.
Thanks, guys.
So up next, we have Kerri. And Kerri, I'm our new co-host, so you are good to go ahead and get started.
All right, just sharing my screen. And let me know when it pops up for you.
Yep, looks good.
Great. All right, awesome. Thank you. So good afternoon. My name is Carrie Rasmussen, and I'm a solution engineer at Esri out of the Charlotte office. And I'd like to welcome you to this presentation on address data management, I should say. On the agenda for today, I'll start with an overview of address management, followed by a look at the address solutions, namely address data management, address field operations, and community data aggregation solutions, then a brief introduction to the Esri solutions page, and conclude with a summary and hopefully some Q&A at the end. Address management is typically a function of local government, and its importance is growing. Assigning addresses is critical to the provision of efficient services and cost-effective commerce in a community. For example, 911, property taxes, utility billing, and delivery services. And with the rise of online shopping and food delivery services, ride shares, address location information is even more important than ever for daily life as well as emergency situations. While many address authorities have a central database of address information, the physical location of those addresses can sometimes elude them. They need a simple workflow that helps capture the physical location of an address early in the development process. For example, when a new subdivision or building permit is approved, a standard set of map products that can be used by key stakeholders to continuously improve their existing address data, and tools to share authoritative addresses with other agencies. The address data management, address field operations, and community data aggregation solutions can be used by addressing authorities to manage road center lines, site addresses, mailing addresses, and aggregate this information from authoritative sources. Let's look more in depth at the addressing solutions. We'll start with the address data management solution. GIS professionals in addressing authorities use subdivision plats, new condominium developments, building permits, and feedback from key stakeholders to manage information in their address repository. This repository typically includes road center lines with address ranges, site addresses, and related postal addresses. Ensuring their address repository supports diverse information needs, including 911, permitting, utility billing, assessment and taxation, is continuously improving, can be challenging and time-consuming. The address data management solution includes an ArcGIS Pro project that can be used by GIS professionals to streamline the collection, maintenance, and use of authoritative road center lines, valid road names, site addresses, and related mailing addresses. This ArcGIS Pro project contains a series of address layers that incorporate content defined in several national guidelines, for example, NENA and USPS, and workflows that help you manage these layers. Let's take a quick look at what ships with the solution. After you deploy the address data management solution, you'll need to download the solution from your ArcGIS Online account to your desktop. Included is the ArcGIS Pro project, address tools, the geodatabase template, and some sample data. Also included is the data dictionary. The data dictionary provides detailed documentation on the solution, including important feature classes, relationship classes, and domains. You can use the hyperlinks at the top to skip to a specific section, or you can just scroll down to view the items. The feature class documentation includes information on field names, types, length, aliases, a brief description, associated domains, and other information. The solution has been updated to include national addressing data standards. There's also relationship classes that show the origin class and the destination class, as well as the cardinality and primary keys and other important information. And lastly, the domains show the complete domain list for all domains used in the solution and the field type and domain type. Address data management includes a set of tasks that can be used to manage address information, add new road names to the master road name table, and use this table to update roads and site address features when road name elements change during the development lifecycle. Derive a road name index from the master road name table to ensure data integrity is maintained on all other addressing layers. Draw a new road in the direction of ascending addresses. Existing roads that are intersected will be split and the address range will be prorated. Update road characteristics and add road name aliases if appropriate. Let's see what this workflow looks like. Using the included tasks, we're going to add a new road. Step 1, we add the road information on the master road name table, including the road name, type, and direction if applicable. Step 2, we want to update the road name index, which runs a geoprocessing tool to update the information that you just provided. Step 3, select the type of road you're adding from the feature template, and then sketch the road in the map in the direction of ascending addresses. And step 4, select the roads you want to update the road characteristics. At a minimum, you want to populate the left from, left to, right from, right to, and full road name fields. Then click apply. And then most importantly, save your edits. Site addresses represent the location of a site or service delivery address. Typically, the site addresses are placed on a structure. Alternatively, they can be located at the center of a parcel or at a location inside the parcel. Site addresses can also include a common place name, for example, the name of a store or restaurant, to help when locating in an emergency. With the included tasks, you can add a site address to the left or right side of the road in just a few easy steps. Let's take a look at the task for adding addresses. Step 1, you're going to select the side of the road for the address and populate the offset distance and number of site address parameters. Then click on the road center line to add the points to the map. Step 2, you're going to select the address you want to update in the attribute pane and update the characteristics for the site address. And click apply and repeat for each site. Step 3 is relocate sites if necessary by selecting them and dragging them to the desired location. And step 4 is add the postal address for the site. Select the site address, click on the arrow next to the address to show the postal address table. Right-clicking, you can add the postal address table and click Add New Relationship. Update the characteristics for the postal address and click Apply and repeat for each postal address. And lastly, save your edits. For the sites with multiple addresses, such as an apartment building or condo, you can associate one or more distinct postal addresses with a given site address, including building, floor, and unit information. Let's take a look at this workflow for adding multiple addresses for an apartment building. Same as last time, step one, we'll select the side of the street for the address. However, this time for the number of sites, we're going to enter 15 for the building and click the road center line to add the point. Now in the attributes pane, you'll see I have a list of 15 site addresses, and we'll update the characteristics starting with the address unit type as apartment and the unit number, followed by a floor for floors 1 through 3. I have 5 apartments on each floor of the building. By selecting multiple locations, I can update them all at once. And lastly, I'll update the unit number. And then click apply. And of course, save my edits. Address data management also includes a series of pre-configured ArcGIS data reviewer checks that can be used to validate, maintain, and improve the integrity of address data. The optional checks are configured to work with the address layers included in the address data management solution. ArcGIS Data Reviewer is a licensed extension for ArcGIS Pro. For more information, please contact your Esri account team. Use the address data management tasks along with the sample data provided to exercise the capabilities provided in the solution and learn how to manage the address information with ArcGIS Pro. Once you're familiar with the solution, use the tasks to configure the address data management to manage your road and site address information. Current and accurate address data is an essential requirement for a variety of functions, including emergency management, as well as administration, research, publications, mapping, routing, navigation, and many other purposes. Successful address authorities assign addresses early in the development lifecycle and improve the integrity of their address repository with quality control procedures that incorporate feedback from stakeholders. Address field operations is typically implemented by planning departments, public safety agencies, GIS departments, and other local government organizations that want to continuously improve an address repository that supports a variety of government functions. The Address Field Operations solution delivers a set of capabilities that will help you solicit missing or inaccurate address information from internal and external stakeholders, verify these submissions in the office, or create work assignments and dispatch staff to verify and collect new information from a mobile device in the field. Address crowdsourcing can be used by key stakeholders to report missing address information. This responsive survey requires a phone number, email, or other forms of feedback and helps stakeholders using an authoritative address repository contribute missing site addresses. Submit a site address and provide details, missing address, building, unit information, contact information, location, etc., that will help the addressing authority quickly validate the missing address. This solution is also a great add for an ArcGIS Hub site, especially if you have a Hub Premium site where users can sign up to help contribute data, just like Matt was just showing. Let's see how this workflow works. The form allows users to enter the street address and building or unit type information. And you'll be able to see that we're using smart form capabilities with the building and unit types, allowing for sub-address information. Users can enter a municipality or city, comments, and add a location on the map. Then users are asked for their contact information before submitting the form. Address assignments can be used by addressing authorities to manage address field operations. Office staff can select a submitted address and assign it to field workers. Field workers can then access the assignment on their mobile device and update the complete assignment when it has been resolved. Let's look at this workflow. We can create an assignment for an address submitted from a crowdsourcing app for field crews to verify before we add it to our authoritative data. We're using ArcGIS Workforce to create the assignments for our field crews. We can also assign our field crews an area where we're missing addresses, such as a new street or subdivision, to collect the new or missing address information. This data can then be added to our authoritative data set. Address field inventory can be used by address staff to collect address information while in the field. It can be used to validate missing addresses submitted with the address crowdsourcing and to capture new addresses observed in the field while responding to an assignment. Using ArcGIS field maps with the mobile devices in a connected or disconnected environment, field staff can verify the original report and record new addresses, along with building and unit information while on site. In a growing number of places, regional agencies, county, 911 authorities, council of government, etc., have assembled central address repositories and are synchronizing address information coming from local address authorities in a variety of formats. Several states have also developed statewide repositories for supporting their counties in development of a system that maintains the delivery data across the state. NG911 or Next Gen 911 is driving the requirements for better, more accurate address mapping so that emergency calls can be accurately matched to the street address. Lives and property may be lost if first responders cannot quickly obtain an address to accurately locate an emergency event. The community data aggregation solution can be used by organizations including states, counties, 911 authorities, councils of government, etc., to aggregate authoritative addresses and deliver focused information products to key stakeholders. Community address includes a data assistant add-in and a sample geodatabase to use to publish a community address layer. The data assistant add-in provides a series of focused ETL or extract, transform, load tools that support the aggregation of address data in diverse formats. So you can create a configuration file to store source and target data sets, persist field mapping parameters in the configuration file, and choose to preview or stage the results before scheduling an address data import. New address data can be appended to a large target data set, or existing data can be replaced using a key field value. Let's take a look at some of the tools that are included with the solution add-in. First, I'm going to start by creating a new file, which will store the source, target, field mapping, and expressions so that we can store this for subsequent updates. Make sure to save your files in a safe location where you can locate it the next time you want to run the tool. Next, I'm going to use the data mapper tool to map my field data. First, I'll add the file that was created in the last step. Then on the Fields tab, I will do my field mapping. You'll notice that after I add each field, I click on the Apply button to apply my changes. This also opens a preview window at the bottom of the pane where I can preview my data and do some QA/QC, making sure that I'm selecting the correct fields. For most of my fields, I'm using the default copy method, which will copy over my data as is. For my full address field, I need to concatenate several fields from my source data. I will use the concatenate method and separate my fields with a space. I select each field in the order I wish for them to appear, and again, I'm clicking Apply after adding each field. So you'll see I'll add the address field, Then I'll go ahead and search for my city, state, and zip. I'm going to add just a few more fields that I know are important, like my state and local FIPS. Municipality. And I'm also going to add some coordinates in there. Now I'm able to use the preview tool. This tool will create a sample data set of 10, 100, or 1,000 features so we can view it and make sure that our data appends correctly before we append it to our large target data set. It will take a moment for the tool to run. Luckily not too long, but depending on how many data points you're looking at, it might take a little bit longer. And this will create a separate feature class for you in your ArcGIS Pro project. So you're able to then come over to the contents page and open it up to view the table. So once I open that up and I'm happy with everything, I can view it and see what it will look like when I bring it over into my target data set. If everything looks good and I'm happy with the way it came out, I can then go up to my Append tool and I can run that. And that will actually move all the data over into the target data set. Now, this one definitely will take a while to run. I have sped it up a little bit for convenience sake for today's demo. So it'll still just take a moment, but a lot faster than it normally would take, because I do have a decent amount of points there for Hickory, North Carolina. And there we go. Okay. And once the tool completes, we could do a quick check and see that the number of records in my source table matches the number of records in my target table. Now, this won't always work for you if you're not starting from scratch, but since I am, I can use this quick little cheat to make sure that all of my data actually did move over. So we're good there. Community data aggregation supports two aggregation models: the contributor model, which allows address authorities to update a community address layer directly on a regular schedule. For example, a city can use the contributor model to aggregate their data into a schema that's required by the county and then send that data to the county, or have that, if they have an enterprise collaboration, they can update the county data set themselves. The aggregator model helps the aggregating agencies such as states, counties, 911 authority, Council of Governments, etc., to update a community address layer with the data that's sent to them by the addressing authorities. In this case, the county would run the aggregator model on the data it received from the city and match it up with their own data schema so they can add it into their own data set. NG911 is a really popular use case for this functionality, and many states are looking to create their own statewide addressing data sets. Now that we've seen what the solutions do, let's look at where you find them. There are two ways that you can access the Esri Solutions site. One is from your browser. I recommend doing a search for Esri Solutions, and that'll usually bring up the page pretty quickly. Or you can launch it from your app launcher in ArcGIS Online or ArcGIS Enterprise as of the 10.9 release. And a quick side note, you'll also need ArcGIS Pro 2.6 or higher to work with the ArcGIS Pro projects and tools that are provided with the solutions. Starting in our ArcGIS Online organization, we can click on the app launcher and then click on the solution app to open it up. You can also use the search bar at the top of the page to search for any solutions if there's one that you know specifically you're looking for. You can use, on the left-hand side of the page, we have select by industry, where you can sort and view solutions that are available for that industry. And to get a brief description of the solution, you can click on it. There you go. And for more information, you can click on the Learn More link, which will launch the Esri Solutions page. On the page, you can see what the solution does, requirements, release notes, and more information. If you choose to deploy this solution, you can do so by clicking the Get Now button. You'll also see, you can also see which solutions you have already deployed by looking for the green check mark. I'd recommend you visit the solutions page and check out the solutions available. They're updated periodically by the Esri Solutions team and fully supported by Esri Tech Support. When you deploy the address data management, address field operations, and community data aggregation solutions in your ArcGIS organization, you will get a collection of maps and apps that can be used by addressing authorities to manage road center lines, site addresses, mailing addresses, and aggregate this information from authoritative sources. The ArcGIS solutions will help your organization capture the location of any addresses early in the development process, continuously improve your address repository, and share authoritative addresses with other agencies. Thank you so much for your time today. And if you have any questions or if you'd like to learn more, please reach out to your Esri account team. And I believe we have just a couple minutes left for questions.
Yeah, we've got about 7 minutes left if anyone has any questions for Kerri.
You could also reach out to me later on. We can provide email addresses for myself or Daniel, who is the account manager that I work with in West Virginia. So,
Kerri, thanks for coming in and presenting. I'm not sure if you're able to make tomorrow's workshop, but it would be great to have you if you wanted to sit in. I know that the attribute assistant changed in the transition from MAP to Pro.
Mm-hmm.
Can you speak about that real quick? Or is that not
well, is there, oh, well, yeah, I mean, there's, most of it's on the back end. There is a very different setup between the two. One thing I will note, because I have a number of customers that have asked me about this, that once you do make that hop over to using the new attribute rules in Pro, that you can no longer use that in ArcMAP. So it's kind of like a, you know, once you make that leap, you're in Pro now, which is not necessarily a bad thing. So that's one thing. If you want to get in contact with me, I'd be happy to talk more about this with you and really go into details with you. So if you have like very specific questions, if there's anything that you're looking for, I'll make sure to put my email in the chat and we can talk more about it if that's okay with you.
Sure. I know that there was specifically quite a few members of the West Virginia addressing community that are looking for guidance on transitioning from MAP to Pro in regards to addressing. So it would be fantastic if maybe we could even set something up later outside of the conference.
Sure.
Like we could do another workshop or something like that. But I know that was a topic brought by several of our members.
Okay. Yeah, that's definitely something we could talk about. One thing I will add is using those aggregation tools. If you already have addressing data that's in ArcMAP that's existing, those tools are going to make the transition over to Pro a lot easier for you. Also, if you happen to have any data that is versioned at all, because I know a lot of people ask about versions. So if you have any data that's versioned, whether it's traditional versioning or if you happen to be in Pro already and you're using branch versioning, we do support both of those with the addressing solutions, just to put that out there. So
okay,
yeah, I'd like to put something together. That'd be great.
Fantastic. Thank you so much.
Thank you. Thank you. Any other questions? If not,
I'll go here. I'm the addressing coordinator for Ohio County, and with our current CAD system, where they're still using ArcMAP, So I'm flipping back and forth between ArcGIS Pro and ArcMAP here.
Mhm.
So that's one thing that I would ask you guys to look into, is to assist some of these CAD agencies that are fraudnet, and to upgrade. What they're looking at is their routing does not work
Okay.
with ArcGIS Pro as of yet.
Okay.
It's something that it's a rather popular CAD system in West Virginia.
Okay. Yeah. I mean, I'm on the local government team, but I'm happy to relay that message over to our partner managers. So thank you very much for bringing that up. I will definitely make note of that. And if maybe you want to get back to me offline, send me a private message or something to let me know
Yes.
who that vendor is. I can talk specifically to that partner manager to see how we can help them.
Okay.
Thank you so much.
Thank you.
Anyone else have any questions? Okay, well, if not, please feel free to send me something in the chat, or I'll put my email in there, and you can always send additional questions to me later on. So thank you so much.
Great. Thank you so much, Carrie. All right. Next up, we have Bryan Walker. All right. And Bryan, I've gone ahead and made you co-host, so you should be able to share your screen if you need to.
We good together?
Yep, looks good.
I'm going to be talking about Mountaineer Gas Company's mobile solution for West Virginia 811. My name is Bryan Walker. I've been with Mountaineer Gas for a little over 6 years now, with my primary focus being when developing GIS solutions, whether that's desktop add-ins or web interfaces or standalone applications, mobile applications, etc. If you're not familiar with Mountaineer Gas, if you're not a customer, we would like you to be a customer. We're the largest natural gas distribution company in the state. We have over 220,000 customers, facilities in 49 of the 55 counties. We maintain over 6,000 miles of pipeline. We have, across our entire area, we have over 450 employees. Within ArcGIS Online, which is the primary focus that I'm going to be talking about in this with this project, we have 400 ArcGIS Online named users. We have over 300 users, field workers in the field using cellular iPads. West Virginia 811, it goes by a couple of different names. Miss Utility of West Virginia. It's on a lot of bumper stickers, billboards, call before you dig. It's a mandated service that if you're going to do any work as an excavator or any work, even around your house in your backyard, if you're going to dig a ditch, you're going to put in a new fence, if you're going to do anything, call before you dig. It's a 24-hour, 7 days a week service. You call them. All of the utilities in your area will be sending West Virginia 811 feature classes in the back end that West Virginia 811 users can compare against to know who are the member companies in that area that could be affected by work being done. So 811 takes in the request by phone or through the web portal, and then they relay that on to any utility in the area that could be, within tolerance, could be have facilities in the area. And then it's mandated that those facilities respond to the tickets created by 811 in a certain amount of time. There's a lot of different type of tickets that West Virginia 811 creates. The highest priority is emergency tickets. So if you're digging a ditch and you hit something, smell gas, you call 811, say it's emergency, we have to respond immediately to that ticket. If it's a normal ticket, like if they're putting in guardrails in your area and they can plan that out, they work ahead of time with 811 to know when that work's going to be done. those could be coming in as normal tickets, and we work those within a 2 business day time frame. Then once we get that ticket, it's our responsibility to go out, work with the excavator to go out to where the work's going to be done and mark any lines that we have in the area, or work with them to say, hey, we don't have lines in this area, you're good to go. Just as an example, in 2020, Mountaineer Gas worked over 53,000 tickets from Western 811. In 2020, pandemic was actually probably a down year for tickets but we still worked 53,000 tickets from them. This project, I started working on it in 2019. Prior to my involvement on the project, and really for most of Mountaineer Gas history here, it's been a completely paper-based system. 811 would either email or fax a ticket to the service center, and there right now, before this solution, there would be 18 different shared mailboxes in Outlook that the different dispatchers at each service center would maintain. And as that ticket came in, they would print it off and require the guy that they're assigning it to come back into the office, pick up a paper copy of the form, and then from the address, kind of call the guy, figure out where it is, not really have a good idea where it is, try to go out and work it based on directions from the task or from the person he talked to on the phone. And then whenever he would complete it, he would put a sticker on that piece of paper, return it back into the office, and it would go into a filing cabinet. So there'd be 18 different filing cabinets across the state with paper copies of completed forms. So it was whenever the PSC would come in to audit this or look at how quickly we're responding to these tickets, they would have to go to a filing cabinet of paper forms. So the goals of this project were a lot. So we wanted to improve the dispatching. We wanted to get away from 18 different shared mailboxes and having a work queue from a mailbox. It's just not a very good system. We wanted to increase our ability to respond to emergency tickets way faster than what we were before. If a guy's one call over a weekend, emergency ticket comes into our 24-hour dispatch in Charleston, they assign a ticket to a person. It would have to be faxed to the site, to the service center. He would have to come back in the service center and print that, take it back out to the thing. So there's always lag time in working emergency tickets with the paper forms. We wanted to expand our accuracy of dispatching because prior to this, with the paper solution, there was no geographical aspect at all to this process. They had no idea what area the ticket was even for, other than trying to just come up with, from the address given on the ticket, where they think that is and whose area that would be in. We wanted to save time and effort by not printing. We didn't want to work from any physical copies. Improve reporting. So all of this being put back into a database, we wanted to be able to report on this. If the PSC asks a question about a specific ticket, if a PSC complaint comes in or anything like that, we wanted to be able to not have to go to a filing cabinet and look for those things. Real-time communication with 811. So 811 has a solution called Positive Response that in their web portal, where a person who puts in a ticket can go look for the status of their ticket to see what utilities have responded, or if they put notes in there saying that it's not in their area or whatever. 811 has a whole web portal for the end user. And prior to this, we didn't have any response to 811. When we would work it, it would stay on paper, it would go into a filing cabinet, and 811, it would just time out of their system. The end user never was able to see an 811 whether we worked a ticket or not. The only way we communicated that to them was by phone. And then a big goal of this project is to integrate this into a tool set of what our field workers are already used to using. With 300 cellular iPads out there, training becomes a big issue. We didn't want to change anything that was going to cause big headaches for people. We wanted to keep it with what they were used to. We've been on Esri solutions for, I believe, 6 years now. and we've been a big adopter of their mobile solutions. And our guys are comfortable with, previously comfortable with Collector, Explorer, now Field Maps. So in 2019, when we piloted this project in the fall of 2019, I made a decision to go with C#.NET with ArcObjects standalone application on the two endpoints, the inbound messaging and outbound messaging. Anything inside of our system that communicates with ArcGIS Online is all done in Python. For our system of record for this, it's all going into SQL Server. The Esri applications that we use is Workforce. When we started this, that was prior to the 2020 rollout of Workforce for offline use. So when we first, in the pilot solution in Oak Hill, this was actually Workforce online only. There was no offline aspect of it. But as you can see, and since we're in 49 of 55 counties, there's a lot of areas in there that don't have cell signals when they go out to work these tickets. So we needed an offline solution. And so in at the end of 2020 or fall of 2020, we converted over to Workforce for offline, and that's what the major rollout of this application is using now. We're no longer using Workforce online. On the back end, chose to go with Geoevent Server for some of the interfaces between ArcGIS Online feature services and also communication, our email notifications, things like that. Geoevent Server is an Esri tool that's an on-premise interface engine that allows you to kind of develop what you would normally do in Python scripts, but it allows you to do it through a GUI interface. We did that just kind of more or less as a test to say, hey, this product's out here. We've seen a lot of demos of it. We want to try it in a pilot and see how it works. So I just took one small piece within the workflow and did it in Geoevent Server. Our major communication within the system is still between C#.NET, SQL Server, and Python. The other applications that is part of this workflow is the field guys using Survey 123, which are comfortable with. Explorer, when we started this, Explorer was still a supported functioning tool, and future of that is going to field maps. So we're in the process of switching everybody over to field maps, which I'll talk more about later on. We've had some issues with. For our dispatching, I wanted to see a lot of demos of dashboards. So we wanted to incorporate dashboards into this workflow. And then for reporting, we're going with SSRS since everything's in SQL Server. That was our easiest solution. So as a first step, I had to work with 811, which is actually Texas 811, who does West Virginia 811 ticketing, to get them to send me XML of all of the information that they have on a ticket. So no longer that text-based, non-queryable format. They now send us an XML message per ticket that I can parse and put into the database. So from their ticket, I parse it out and I'm able to create points for where the work's going to be done, a work area polygon, and then a buffer around that of where they think the work's going to be done. And I put all that into the SQL Server. So then once it's in SQL Server, I use Python to pull any features that need to have assignments created for them, and take all of those feature classes that exist in the database and put them out onto ArcGIS Online, and then also Workforce. So they're out there in some feature services on ArcGIS Online, and then also in the Workforce application. So once it's out there, the dispatcher is then able to see the ticket in their dashboard. This is an example of a dashboard created. We have a lot of different type of dispatchers. For our 24-hour dispatcher, emergency dispatching in Charleston, they only care about emergency tickets. They don't care about normal tickets that are going to be the work's going to be done 3 days later, they really only care about the emergency ones and getting them out as quick as possible. So they can go into a dashboard like this, choose the assignment type at the top, and they care about our entire service area. So they're not caring about just Oak Hill or just Charleston or just Huntington. They're caring about the entire state, and they care about emergency tickets. So they can go in here and filter this down, see how many of them are out there that are unassigned, click on just the unassigned ones and pick from it, assign it to a person immediately, and it would go to their iPad. For other service centers who work differently, so like Charleston, they have dedicated locators. That's their job. They get so many tickets in Charleston that they have designated job. Their sole purpose is to locate. That dispatcher would choose Charleston area office. They don't care about any other area office, and they would choose all type. So then they would sit here and assign normal tickets as they come in. That guy's got 2 days to go out and work it, assign it to, a specific person, not based on where the ticket is. We just know that guy's going to work it. Some areas, based on where a person is during the day, it may not be assigned to, it may be not being assigned to the right person geographically. Some people can, say like in Beckley, if you are a serviceman that only works the northern part of Beckley, you're not going to be wanting to assign a ticket to him that has worked in the southern part of the Beckley, which prior to that on paper, there was no concept of. They would have to call, work that out with whoever it was supposed to go to, and eventually it would trickle down to the right person. Right now they can go in and look to see where the ticket is on a map and then assign it to the correct person. The map control was very basic. I didn't want to overload dispatchers or workers. I mean, the workers already have they have mobile map package of our entire network. They didn't need to see a whole lot of data to be able to go out and work one of these tickets. So I kept it very limited on what they're able to see. In this view, on this slide, so the blue line at the top is actually our pipe network. That's when you want to locate, that's the most important thing. Where is our pipe network in relation to where the ticket is? The green line, solid lines, the work area, the dotted lines, the buffer area. The point in the centroid of it is one that I create to show what type of ticket it is. So they can just look at this map, know immediately, is this an emergency ticket or is this a normal ticket? What do I need to do? And then the only other feature that gets pulled down into their offline map is the assignment itself, which changes between unassigned, assigned, completed. So I wanted to keep it pretty simple on the actual map control that gets pulled down into their offline map, as well as seen by the dispatcher. It's the same view. As far as once it's with the dispatcher, I went over that a little earlier there, but they assign a ticket to a field worker based on rules of different service centers in different areas. That field worker gets it in Workforce. They can do a lot of different things within Workforce with that, but the ultimate goal of what they're doing with it is they're going to, in Survey 123, complete a locate on it. Once they complete a locate, here's where the Geoevent interfaces that I put together come into play. It's setting out their poll in Survey 123 at all time for positive responses. Whenever it comes in, it completes the assignment. The Geoevent interface completes the assignment in Workforce, which takes it out of their queue, takes it out of the person working its queue. They're also going to be completing all of those features that they don't live out there forever, because if they did, the Charleston downtown area would just be a jumbled mess of green boxes. So it goes out there and completes all the polygons and points related to that ticket whenever they send in a Survey 123 survey. It also puts it back into our SQL Server database. At that point, the dotted line here, the positive response, is actually another standalone .NET application. It takes in the feature for the survey response, goes out to A11, a REST endpoint, sends them a response with all of the information from the Survey 123 survey. Like if a field worker puts in comments, our lines aren't in the area, or yes, I marked it, or whatever, all of those go back into the positive response and show up in A11 now. So I didn't want to get into a huge amount of detail because, the glamorous back end of this process. but this is a Geoevent Server interface. This is one interface in Geoevent. I could create it faster in Geoevent and it look pretty, but this same function can be done in Python. It doesn't have to be done in Geoevent, but it was a new tool that I wanted to try out. And but this is an example of some of the interfaces that we have out there running right now. And it's an on-prem service that sits on top of server for ArcGIS. We're running 10.7.1 right now for this Geoevent. The field workers view, they're used to working on the iPad with Esri applications. They get a to-do in. The big difference here is that they're downloading that workforce project offline and syncing it, sometimes removing the project, adding it back based on issues. But so they get a to-do in their list. They go out to work it. They see the point on the map. The 4 functions at the bottom of the screen are things that all of the field workers are pretty happy with. They can get term return directions to the point on the map now, just out of the box. They can explore at the assignment. This is now going to be replaced with field maps when Explorer goes away here. But if they need to see more detailed information about the customer, the pipe, if there's leaks in the area, anything that they need to know about that's more detailed than what I'm already giving them in the workforce assignment, they can explore at assignment. It'll bring up the Explorer map with our pipe network and all of our features in it at that area that they can look at. Most important one probably is surveyed assignment. So it's going to bring up the survey. They have several questions they have to answer to complete a survey. The status of the status of the locate. It's tied back to the ticket number and the assignment ID from workforce. They complete those fields, enter some comments, and send it back. Whenever that's picked up and the workforce assignment's completed, the .NET application sends back the positive response I was talking about. This is an example of the 811 portal, and as you can see there, American Electric Power, they sent back a message saying clear on September 8, 2020, 11:07. We sent ours back saying that we went out and located it. Line, it was painted 3:09 p.m. None of that concept existed in the previous solution. So I think everyone's really happy with that, to be able to give the end user real-time notification of surveys being done in the field in 811 system. Reports for management. As we get audited or as issues come up, if the complaint comes in, there was really no good way of reporting on these things before, or having any concept of quickly looking them up. So now being able to do this in SSRS, where we give a manager the ability to go out with the ticket number and look up detailed information on it, is very helpful. They can look at time range. This is just 2 example reports I pulled in here. They can look at a time range, the service center, to say, hey, this guy's been out here, he's worked 5 tickets on this day, et cetera, et cetera. Conclusions and takeaways. Overall, it was, I believe it was an extremely successful project. Started in 2019. We kind of had some updates immediately with workforce, things we were waiting on to get over to workforce for our offline. But as far as end-to-end user experience, I think it blows the old solution out of the water. I mean, we've improved dispatching with our dashboards and also just the workforce app. Our response to emergency tickets are now immediate. Since the guy gets it on his iPad, he can go from home and start working it over a weekend. The accuracy of dispatching is going to greatly improve as we start to do this, and the dispatchers get more comfortable with looking at tickets where they are on a map. We don't have any physical paper in this solution. The reporting's immediate since it's SSRS. The 811 positive response is now showing up in the portal, and we're using tools that our guys are already comfortable with. Moving forward, we had a good bit of issues with, we were early adopters. We were in the beta for Workforce Offline, and we did have a lot of issues going from online to offline. I don't know if anybody's familiar with the way that the offline areas work in web maps, but the Workforce for Offline doesn't work that way at all. There's no live version of Workforce. It's all offline. So once you convert your project to the old Workforce solution to the new offline solution, you have no way of viewing it online. It's all going to be downloaded. and the user is going to have to sync. And some of the issues we've had with that is a lot of sync errors. If they sync and lose connection in the middle of it, they have a lot of issues. The notification process of it, push notifications on iOS is a pretty simple, common thing. But with Workforce Offline, it doesn't really work that well. It only syncs every 15 minutes, and it will only send you a push notification when it syncs, and it won't sync in the background. So they have to have it up and syncing to get a push notification. So with that, I had to go through and set up a lot of email notifications, since Office 365 does way better with push notifications, and those will be sent whether Outlook's running or not. It will run in the background. They'll get a push notification. It's actually coming from Outlook, but it is me sending them a notification to say, hey, you got a workforce assignment. So we've had a lot of workarounds with syncing and notification issues. The future of workforce is going forward. It's supposed to be rolled into field maps. I don't really know. I mean, all these things are going to affect our solution and the way we go forward with this, but the future field maps kind of taking over workforce and it being incorporated into it and how that affects us. ArcGIS Online versus Enterprise. We went to ArcGIS Online about 3 years ago, I think. We still have an enterprise solution on our network, but it's not exposed where guys can hit it from the field. So we're still kind of in a constant debate about, how much should we do in enterprise? How much should we do in ArcGIS Online? And then just the overhead of Geoevent Server. Geoevent Server is it's a pretty neat tool for some shops who may not have technical staff and just need a workflow that they can quickly create an interface of and hit play on. It's a really good solution. But for us, does that make sense? Because supporting, I can create it way faster in Geoevent Server than I can just write some custom Python. But supporting it, troubleshooting it, Geoevent Server is a black box. I have no control over it. Within Python, I have complete control. So for us, I don't know going forward as we do other solutions. I mean, we have several other solutions we're working on that are similar to this right now. I don't know that Geoevent Server is going to be something we continue to go with. I think that's it. Questions?
Okay, great. I didn't see any come in the chat while you were speaking. If anyone has any questions, feel free to raise your hand or go ahead and chime in. We've got about 6 minutes.
Bryan, that was really well done, really impressive. I may have missed it at the very beginning. How are you getting the initial contact from 811? Is that an automated process, or is that something you have to?
It is. They send it's through AWS, through an AWS service. They're sending in an XML message per ticket. Yep. And I kind of glossed over that because a lot of the details people may not want to hear, but yeah, it comes into us as an XML message through a AWS service.
This is the group that wants to hear those details.
I know you would, Kevin. I know you would.
Are there any other questions?
Okay, one more question. So I understand getting it pushed back to or pushed out from 811, and then how do you have, is it like the same system in reverse that sends your completed messaging, like a task has been completed? How does that work?
Are you saying back out to 811?
Yeah.
Yeah, so it's different. It's actually different. Yeah. So they have a HTTP request that the other utilities use. So we just went along with what they were doing. So I actually send an HTTP out to a REST endpoint that completes it. So they have a task ID that they're expecting, and then any of the other information they're expecting in an XML message, and then I package that up and send it back out to the REST endpoint. So yeah, it's different on the way back out than it is the way in. But yeah.
Pretty neat.
I don't know how many people are using the inbound way that we're doing it. So I think it was kind of more of a one-off solution, but the way back to them with positive response, several people use.
Cool. Thanks for presenting today.
Yep, no problem.
All right. Well, thank you so much, Bryan. Next up, we've got a shorter presentation, a 15-minute presentation from Aaron Maxwell, Manish Sharma, and Donaldson. I'm not sure. I think I've made all three of you co-hosts. So whichever one is going to be taking the reins with the screen sharing there, you should have that ability.
Okay. Is my screen share working now? Should be.
Yeah, there you go.
Okay, cool.
Looks good.
All right, so hi. Okay, so my name is Maxwell. I'm a faculty member in geology and geography at WVU, and also work with the GIS Tech Center in the state. So what I'm going to talk about is a project that we've worked on over the last couple of years in the Tech Center related to geohazard mapping using machine learning and LiDAR-derived terrain characteristics. Before we get into the nuts and bolts, just wanted to highlight some of the key people that have worked on this project over the last couple of years. So this project was originated by Kurt and Maneesh before I was ever involved with the Tech Center or in the project. So they secured funding and they manage everything. So they're kind of the leads. We had some other faculty at WVU that were involved early on. So for example, Steve Kite is a geomorphologist in our department who recently retired, but he helped with a lot of the front end work in terms of like identifying landslides and whatnot. And also Jim Thompson, who's a soil scientist in the Davis College here at WVU. A lot of the day-to-day work has been done by our graduate research assistants and researchers at the Tech Center. So Shannon and Matt and Caleb are some examples there. If you're interested in the data, there's a web service. It's if you just Google West Virginia landslide map, you'll find it. But that shows our models and our inputs and our validated or located slope failures among some other data layers. So the main thing I'm going to talk about is just kind of the results of the modeling processes, since that was what I was mainly involved with, and how we've spun that into some like research papers and stuff. Some other quick notes. The slope failure data is also available through the West Virginia Flood Tool under this risk map area here, and then also the community profile dashboard. All right, so a couple key things happened to make this possible. So one is that we are now starting to develop a really large LiDAR coverage for the state that hadn't really existed up until recently. I pulled this just a few days ago. So we don't have a complete coverage yet, but the Ohio Valley is due to be delivered fairly soon. So within the next year or so, we should have a full LiDAR coverage for the state. And as you can see from this set of images, with the amount of detail it's the LiDAR provides, you can actually photo interpret a lot of these slope failures. And that's just not possible with the existing data. So with all this new high-res LiDAR-derived data coming in, we can actually like create inventories of where there are slope failures. And what we're really doing here is machine learning, which is learning from examples. So you pretty much have to have those examples up front. You can't really do anything. So unfortunately for our students, once all that happened, they had to go through and hand digitize all these different landslides to feed into the model, which was, as you imagine, a lot of work on their end. So this kind of highlights our overall modeling process that we use and workflow. So again, we have a bunch of samples that represent slope failures, or generally the point of initiation. And then we have a set of predictor variables, which we'll talk about. Basically, we get all at every location where we have a slope failure, we extract out all of the predictor variables that we're going to use to make our model, and those become our sample points. And then once we have our sample points, we train models, and that once we have those models, they can be assessed or used for inference. Because we did this for large extents, it's not possible to throw these large data sets into the system at once. So we run all of our processing on a tile by tile basis and then merge the final results. The output is a probabilistic surface. So it's basically low to high probability. This is showing that surface is turned sideways. So this is basically Germany Valley here, and then this is going east across the valley and ridge. So the red indicates predicted likelihood of high slope failure occurrence, so high risk areas, and then the greens are the lower risk areas. Again, it's learning from examples, so you pretty much have to have two sets of inputs, some locations of occurrence, and then you also need to have some variables that would be predictive of landslide occurrence. So the majority of our variables are things that were derived from LiDAR and were based off of, or tried to model or characterize the local terrain characteristics. So things like slope position, topographic roughness, topographic dissection, different bases of curvature. So there were some other variables we looked at that were not terrain related or derived from the DEM. So for example, soil wetness characteristics, soil parent material, bedrock geology, like the formation or unit that's there, the rock type. And then we also had things like distance from roads, distance from streams, that also could potentially be indicative of a landslide occurring. And then the modeling method that we used was random forest. There's lots of different machine learning methods now. Random forest has, like any method, strengths and weaknesses. We went with this for this project because, one, it can handle fairly large feature spaces or a lot of predictor variables. It doesn't care if the predictor variables aren't like normally distributed or they're on different scales. Some were even categorical, while others were continuous. So it can deal with that complex space, and it also can give you back a probability as opposed to like a hard classification. So it's not just slope failure or not slope failure. You get back basically a probability of being a slope failure. So that was our algorithm that eventually generated a model which we used to infer to every cell where we had LiDAR data in the state. We assessed our model in a couple of different ways, tried to rely on like quantitative methods once we had a visual assessment that we were getting something that looked reasonable. So we relied on a lot of binary methods like precision recall, F1 score, sensitivity. These are all based on the numbers of false positives and false negatives versus the number of true positives and true negatives. So in this example, a true positive would be a site that we said was a slope failure, and it was predicted to be a slope failure, or there was a slope failure and predicted to be a slope failure, whereas a true negative would be something that wasn't a failure and was correctly predicted to not be a failure. And then obviously false positives and false negatives are sources of error. We also looked at some measures that look at the data in a more continuous way as opposed to like a hard break, specifically precision recall curves, which plot precision and recall, and ROC curves, which is precision and recall and specificity. All this work was done in a couple different environments. So initially my goal was to do everything in one environment, but different environments have different strengths and weaknesses. So we instead relied on what we were most comfortable with, what methods we were most comfortable with in different working environments. So we use ArcPro and ArcPy for a lot of the data prep, data summarization, data extraction. This was all wrapped inside of Python. Some of that was ArcPy, and some was like some were more open libraries. But the actual modeling component we did in R because I was just more familiar with that, but it could be done in Python. So effectively, we had a stack of Python notebook or Jupyter notebooks. They ran Python code and called it out to run sub-processes in R. So that was kind of the software stack that we were looking at. So I just wanted to highlight some of our key findings from working with and analyzing this data. So this paper came out last year, 2020, and this was some results from the initial phase of the project where we did mapping in the Valley and Ridge portion of the state. And this is an open access if you're interested, so you can just Google it and download it. So again, this was just for the Valley and Ridge part of the state. Here you can see examples of the output model that we got for the entire state, the entire Valley and Ridge. And this is a 2 by 2 meter resolution. So each prediction is made in every 2 by 2 meter cell. So some of the key findings we found from analyzing the data was, first off, the most important predictors of creating these models are really things derived from the DEM to characterize the terrain. So this is an ROC curve, and the point, basically how you interpret this is the higher this curve is up on the graph or away from this dashed line, the better the model. So you can see just feeding the algorithm predictor variables related to distance from roads and streams produced a fairly poor model. So you can see the AUC was 0.67. Those are generally interpreted like grade scale, so 0.9 above an A, 0.8 above a B, so on and so forth. So this is like a D range. And then with the using just soil and lithology was better, but up to about a 0.8, or sorry, where are we at here? Oh, sorry, 0.67 there. And then, but as you see, the best models were the ones that either were just the terrain variables, which I believe is the blue line, or all the variables. But actually incorporating variables that were not terrain based didn't actually improve the model over just using the terrain variables. So effectively what we found is you can create fairly decent probabilistic models just using terrain derivatives from a DEM without any other ancillary variables. We also found that the model was somewhat sensitive to the number of training samples we had, or slope failure occurrence points. And that's outlined here in this graph. So, so AUC is a measure of accuracy. So as you can see, the more samples we added, the accuracy improved. It started to kind of plateau a bit after 200 samples per class, but you can see slow, steady rise there. So having a decent inventory of slope failures, a large inventory, an accurate inventory is generally really important for doing this type of work. In contrast to that, if we look at the number of predictor variables we provided, it actually could do a pretty good job with only a subset of the predictor variables. So it plateaus pretty quickly. So this graph shows an estimate of what variables were like important in the model. So for example, some of the most important ones were slope, surface area ratio, cross-sectional curvature, surface relief ratio, plan curvature. So we just gave the model that first set of variables that were most important and ignored the rest. It generally did just as good as giving it the entire space. And then just recently we had a second paper come out on this from this project, which is also an open access, using all of our different models from our different physiographic regions. And our main goal here was to try to assess how well these models that we generate in one physiographic area with certain terrain characteristics port or extrapolate to new areas. So again, in this one, we compared 4 different areas. We had the Central Allegheny Plateau, which is effectively the Ohio Valley, the Cumberland Plateau Mountains, which is like the southern coal fields, the Eastern Allegheny Plateau Mountains, which is like the Allegheny Highlands, and then the Northern Appalachian Ridges and Valleys, which is the Valley Ridge. So effectively what we did was we trained models in each of those areas, and then we took that model and used it to predict all the other areas. Again, the goal here was to see if we really needed localized models to get good performance. And generally what we found in these cases was that the model trained in the area did a statistically better job than any of the other 3 models when predicted into that area. So for example, this is basically the higher the bar is, the better in this case. So this is AUC and from the precision recall curve and ROC curve, and this is overall accuracy and kappa statistic. So it was always the model in the area that provided the best performance. But the variability was not consistent across different regions. So for example, the Eastern Allegheny Plateau Mountains, as you see here and also in the graph, the other models did a decent job predicting it, even though the model in that area was the best. In contrast to that, like the Central Allegheny Plateau was poorly predicted by the other models. And you can see that here with the variability in these different curves. So these are all pretty tight, so they're really similar, whereas the Cumberland Plateau Mountains, for example, are more dispersed in like the southern coal fields or in the Central Appalachian Plateau. And again, we saw pretty similar patterns with what variables were important in the models. But the ones that were predicted were harder to predict. They generally had a wider variety of variables that held importance, whereas the areas that were easier to predict, they tended to have a subset of variables that provided most of the useful information. Okay, so I just wanted to note that if you were interested in doing this type of modeling, like in another area, we had a student in our program, so it's over here, put together some of our code into a GitHub repo. So we created a set of code examples that just rely on Python, and another set that just rely on R. This is pretty slow. So the idea, this isn't really the code we use, it's a cleaned up version. And the goal was to try to create a set of useful code that you could use in one environment, Python or R. So those are resources that are available. Okay, and then so anyway, thanks for listening. Here's my email if you're interested in contacting us, and then obviously the contact info there for the tech center.
Great, thank you so much, Aaron. We've got about 2 minutes if anyone has any questions for him. And if not, that's fine. Okay.
So Aaron, how difficult do you think it would be to adapt that to another type of phenomenon?
I think a lot of it depends on whether, like, the signal that you can extract from your variables, and also whether or not you've got enough training data. So if it's something that can be well mapped, that you can create a decent data set, and there's a signal that you can differentiate it from the background, then generally you can get decent predictions. But it's kind of a case-by-case basis. It really just depends on the complexity of the problem.
Yeah, the example I was thinking of was low head dams, which tends to be in the stream and have a specific aerial signature.
Yeah.
Good work.
Great. So we can go ahead and move on. The next group is Manish Sharma again with Kurt Donaldson and Eric Hopkins. So I'm not sure who's going to be screen sharing. Manish, is it you?
So I'm Manish. I'll share the screen.
Yeah.
Can you see screen now?
Yes.
Okay. So you can see the presentation, right?
Yep.
Aaron just talked about the landslide part. So I'll present on the flood part, flood part, but I will give a overall whole project outline and the different aspects of it. So this is about the statewide flood risk assessment. So this is a big team with Kurt and Frank and Eric and everybody else. I'm sure I'm missing other people here. We have our all full-time staff and senior grad students who are part of the team, plus a big team of students who are working on this project. A quick outline. So first I'll talk about the flood risk, this project overview, and then how we are assessing the building level risk in terms of building inventory, the models, the community outreach. And then the next part I'll discuss is about the flood tool, where all the result is going. And then what's we are going to do now after that, the next things. So this is part of the FEMA project. It is a multi-hazard risk assessment project. We were awarded this through state from FEMA, and we are trying to assess both flood and landslide risk in the state. The third aspect of this project is reference data development. And so Aaron presented on landslide. Kevin Kuhn will be presenting, I think, in another group about the data development, if not in this group. And I'll talk about the flood risk. And all this study we are doing at building level, at flood risk structure, and this is all like a statewide study. This is a multi-agency coordination effort. So it's just not tech center, it is like FEMA, other federal agency, Corps of Engineers. We are collaborating with them, different state agencies, regional council and local communities, where the feedback and the community outreach becomes critical. And then with collaboration with private entities as well. So the way the project is being approached is, if we look at it, we have 294 statistical geographies in West Virginia, which forms 286 communities. And these communities include both incorporated areas and unincorporated areas. And those 286, they form 55 counties, which in turn 11 regional councils, and then whole statewide. So we can stack this in this way, but we can also approach in terms of the granularity of how at building level, how we want to assess the data. So this table shows those 286 communities in different regions. Out of 286, what we see is there are 18 communities which either don't have a special flood hazard area or they don't participate in an FIP. So in the end, like we have 268 communities which are part of SFHA. So in this assessment, obviously, like whatever we are generating the products that will get published, most of it will get published on the flood tool and its accessory products. But the overarching goal for this is, like what we are trying to identify is what is at risk in West Virginia. And part of that is we are also trying to quantify the mitigated structures in the state. And so what is at risk? And then what we are trying to identify once we do that, then what is the degree of risk in each community and then for the whole state. And hopefully, once that gets quantified, these flood-prone communities, they can identify the potential mitigation projects, right, which are consistent with their community's goals. So all this effort is being done to support local or state hazard mitigation plans, to support the floodplain management activities, communities which are trying to move towards CRS. Hopefully all this activity, it can get counted, different points towards the CRS activities. And whenever a CAB visit happens, community assisted visit, all this data set that can form a baseline on which communities can improve the data set, and it can help in that. So the flood risk, what we are trying to do is modeling at 1% annual chance flood event for all the structures. 1% colloquially, sometimes it is called 100-year flood event. But that 1% annual chance is for all the primary structures except for essential facilities. Essential facilities are assessed against a higher standard, so that's 0.2% annual chance, colloquially called like 500-year flood event. So to do that modeling, two parts, right? So first we are trying to do detailed building inventories. So we are defined user-defined facilities or primary structures. And all that data we are trying to improve, and it is going into the central database, which we call FRAGIS, Flood Risk Assessment GIS database. So it's getting integrated at a state level. And hopefully once that all is finished, it will help us identify gaps and deficiencies in the areas. And the other big component of the modeling is depth grid. So in the statewide depth grid, two big components. One is like HACRAS depth grid, which is engineering-based depth grid. So we are using that. And the other is HAZAS depth grid, which is not that accurate. But if HACRAS is not available, then we are using that so that we can get damage estimate. So these two inputs we are using in FEMA's software, FAST, which is a Python-based flood risk assessment structure tool. And we are using that to generate the damage loss. So once we do that, the outputs are coming out, and that will get used to generate analytics, right? Report, and this thing will get published online on Flood Tool. So once we are done with this part, then field verification and community engagement. We are trying to coordinate and talk to different communities in the state to get their feedback and to improve the data set. So this is a diagram showing what I talked earlier. So the data input, the flood zones, depth grids, building stock. Then what we do is, like, we are trying to improve the accuracy of that. Right? Then we run it through FAST. The data output comes out. We publish it on Flood Tool. The tabular outputs are there. So all this output, then we are doing Zoom meetings with our community counterparts and trying to get their feedback. If inputs we are using, there are some inaccuracies there, how can we improve it? Once we get feedback from them, we try to improve our original data set, again, rerun the models. So it's a cyclical process, like it's not one and done thing. As and when we get the new data set, we rerun the model and we republish the data set so that all the data set, all the results are up to date. So I'll start with this first data input, the building stock. So in this building inventory. And building inventory is pretty important, right? So for anything, to have a more accurate assessment. So for example, in flood hazard area, if we want to have building count, we need to have our correct building inventory. Elevation certificate, we need to have the correct location of the buildings. Repetitive loss, we got the data set, almost half of the data set is not at correct location. And so anything we do, mitigated structure, so we want to know the correct location. So building inventory became the primary thing to do anything. So in terms of building inventory, when we start, so we are defining it as a primary structure. So as per FEMA or CRS, like definition of building in primary structure is 2 or more exterior walls and a roof affixed to a site. That's the primary definition. And mobile homes are also considered primary structure. Travel trailers are also considered if they are without wheels. If they are on wheels, and then they are not considered a primary structure. And what is not considered a building? So like open pavilion, if there are no 2 affixed walls to it, or like an accessory structure like a standalone car garage. So the thing we focused on was the primary structure. We did not consider these accessory structures as part of the study. So when we started on building inventory, the first thing was to identify the primary structure point, right? And we needed to get the point exactly on top of the primary structure so that it can be accurately modeled. And to verify, then we enhanced the attributes of that primary structure point. We verified the E911 data. We used the parcel assessment data. There were like shift in the parcels, things like that. We had challenges with that. We used the aerial and the street views. Building sketches were used. We also determined the characteristics in terms of occupancy class, cost, basement, foundation type stories, etc. And whenever we found any issues, we had like manually defined the overriding values. We had the modified building characteristics. So basically we called it user defined values. And those user defined values got used in the models. The other important thing we did was we tried to ensure that the building point was in the most restrictive flood zone. So for example, if primary structure is within floodway or flood fringe, we try to make sure that point is in the floodway. And as I said earlier, this is an iterative process. So once the QC was done, we tried to make it more accurate and just go through the cycle. And hopefully, once the building inventory got finished, we recorded the data issues. So hopefully that helps to identify the data gaps for each community. So primary structure. So the first thing that stood out was building identifier. How do we do the building identifier? So we created a new building identifier in terms of like, we have the parcel information and then we have the address. So we took the parcel information underscore, then the address number. So we wanted to have redundancy in the building identifier. So if one doesn't work, we can use another one. So first we had this building identifier. If in case something goes wrong, we have the XY coordinates. We have the Google Plus code. And then in Flood Tool, you have the, this link in the Flood Tool or in the assessment viewer. So hopefully, like if one thing goes wrong, the other identifiers work. This slide shows you where the share link works and where the different identifiers are in Flood Tool. The last one you see here are parcel information, right? And then the address, the other identifier, lat long. In search, in the drop down, there is also, it's searchable by building ID as well. So once the building inventory gets done, its first round is done now. So it's not just the inventory got done, there are a lot of tangential benefits to it, right? So at building level, then GIS files are getting generated, the maps, the tables, the reports, which are getting out of models. And all this goes to the Flood Tool. Then at the building level, because we have other attributes associated with it, 3D visualizations can be done, data gap reports, and hopefully then mitigation action recommendations for communities. This is one of the image of students working on the building inventory in Tech Center. So other part of, I talked about the in building inventory, but it's like residential, all the primary structures, but then like we are also dealing with the critical infrastructure at building level. So in critical infrastructure, two things, essential facilities we are looking at and the community assets. So the essential facilities in 0.2% flood chance area. So in this, we are looking at police station, fire, E911, school, hospital, and nursing homes. For community assets, we are concentrating on religious institutions, national register, different utilities, and government buildings like libraries, any other entities that we can identify. We are adding to the building inventory data set. So talking about the building inventory, the other big component is trying to identify the mitigated properties in West Virginia. That helps us in terms of accurate count. So that, and the flood loss also. So if you see the mitigated properties, two things, right? One, for some structures, we get elevation certificates. In other cases, like properties get bought out. So on Flood Tool, it gets represented in this way. You know, if there is a buyout property, the parcel shows up there. Elevation certificate, it's really helpful because it tells us about the elevation on that structure, and that helps us to accurately model in terms of the loss and represent. Then that can be represented on the Flood Tool. So the elevation certificates which are important to us are like 5 to 8. I mean, any elevation certificate gets hosted on the Flood Tool, but 5 to 8 are really important in terms of assessing the building loss. So if you look at any elevation certificate, at the end, there are like diagrams for it. So if you look at building diagram 5 and 6 here, these are the elevated ones, which are on piers, posts or piles or columns. So the only difference between 5 and 6 is if you see the 5, it's totally like empty. It's totally open here. Nothing is there contained. But in 6, there is a partial enclosure. So if you see in this building here, there is a partial enclosure where they are keeping some stuff. So that's the only difference between 5 and 6. So it becomes important, like if we don't know, if we get the elevation certificate, we can get the accurate height, then we can accurately model it. So this is building diagram number 7 and 8. So 7 and 8 are related to the basement. And 7 is like full story enclosure here. And 8, you see like there is a crawl space. So it's like the full floor thing here, and it's the partial. So that's the only difference here. So that completed the part of building inventory. The second big component in terms of modeling is your depth grid, right? And all that goes into HAZA's FAST model. So this is a diagram which I took from FEMA's FAST site. So what it is showing here in terms, you see the input. So that's where your user-defined facility is going. You take the depth grid, you run the models, and the output comes out with economic loss. So I'm bringing back this slide again just to show where we are. We did the data inputs, right? We improved the accuracy on that. We ran fast. So now we have the outputs. So what do we do now? So we publish that on the flood tool. We have the tabular output, and we are right now in the community engagement phase and working on getting the more accurate results. So I'll talk more about now where the data is going. So on the flood tool, just a quick review of flood tool. We have a desktop version and a mobile version of the flood tool. The flood tool links to assessment viewer, and likewise assessment viewer links to flood tool. So everything is linked together. If we look at the flood tool, we have 3 views there: the public, the expert, and the risk map. Public is the quick determination in and out. If you want to know whether you are in flood zone or not, you just use the public view. Expert view is for floodplain management and permits for floodplain managers and other experts. And the risk map view is the last view, which is where everything building specific flood risk assessment, that's where things are going. So this is one screenshot of the public view. Not much has changed there in terms of risk assessment because this is supposed to be a simpler interface just for quick in and out check out of floodplain. Just a reminder, the red shows the regulatory floodplain and the orange shows advisory floodplain. On the expert view also, there have been minor changes, but not much in terms of any risk product. They are not part of this. So when we look at the risk map view, that's where major changes have happened. So you click on that, and then this tab here, the risk map. So this is where all your building level risk assessment data set is, like future map condition. So you see different symbology here. I'll go in detail in next slide about this squares and circles and star mean. But if you see here, we have building exposure cost, pre-firm and post-firm, foundation type, minus rated structures. So all these results which came out of the risk study, they are part of it here. Then we have critical infrastructure, other mitigated properties, and open spaces. All these are new here, and they are all part of risk study. And the other big change is like when you click on a point, your query panel comes, you have this flood risk information. And there it is like this flood risk assessment. Once you click on that, this new tab opens here. And what this tab is showing you is like first tab is for address, then parcel, then the risk tab. So the first part of the risk tab in this, it is showing you all the building information, right? The replacement cost, the content cost, square footage, things like that, pre or post firm. It also tells you the first floor height. Remember I talked about the elevation certificate? That's where it becomes important because it is showing the water depth in a structure. So if it was elevated 10 feet, so then it won't have any water depth in a structure. That's why the elevation certificate are important. And we are trying to get that accurately, get that information accurately in the database. So first part shows that. And then the second part here, flush damage estimate. This is what output comes out of the models. So this is showing you how much damage will be there, right? Building loss and everything. So some of the symbology, like in the previous one, this all is new symbology here. So in the flood zones, we have floodways, regulatory, non-regulatory, and then building exposure, building physical damage by percent, by dollar, critical infrastructure. So a lot of different symbology has come in risk tab. So that yellow color, purple color things, which we are showing in the map, that is like future map condition. So what we are trying to do is like when we modeled it, in regulatory flood zone, the structures which we modeled in regulatory flood zone, they always remain same. And if you see this star, that means purple color always means highest risk. So this is like floodway. This, you are seeing the hexagon here. It red, that means it's still in SFHA. So these two, they remain same. Then in advisory flood zones, you see mapped in. Mapped in means whenever in future FEMA comes and does restudy, there is a potential these structures will get mapped in into the floodplain. So these are like potential structures which right now can get preferred flood rate policy. If they get a flood insurance, they can get a preferred policy. Then there is mapped out. The mapped out structures are potentially our first cut on that, whenever FEMA comes and does restudy, we feel like that might get mapped out. So a more detailed analysis at whenever somebody is trying to get a LOMA or ELOMA, they need to look into detail that whether it is possible to get this structure mapped out. We have minus rated structure, which is showing the whether the structure has will get inundated with at least 1 foot or more of flooded water in the structure. Then we have the new basement. So everywhere you see the symbology theme, which is following is like purple, and then gradually it goes down. So purple means like most intense. That like damage estimate. If you see purple color at the bottom here, that means 50 to 100. So that means substantial damage has happened. So that's not good. This in the context of the map, future map condition, I thought it was good to show in terms of map context. So you see here star right in the floodway. It shows up this way. Here you see these hexagons. So not in the floodway, but still in SFHA. These orange zones, they are either advisory or we did redelineation using the new DEM, so updated AEs. So these orange ones, they can get potentially mapped in whenever FEMA comes and does the restudy. And these yellow ones, they can get potentially mapped out. And then you see C, R, and O, they are for commercial, residential, and other. So this is one of the examples, actually, Howard Creek. So you see FEMA, this is a draft floodplain of FEMA. And these we had like potentially, see this got mapped in. These are $1 million structures which are potentially getting mapped in. And these, some of these here, they are getting mapped out. And some of this, like initially we had it this way. So, I mean, it's bad for them. That's like multi-million-dollar properties there. And this is the symbology for building exposure cost. So more than $1 million for each of them. So in purple color, that's how it is getting shown on the flood tool. So so what's happening next? Like we have completed the whole statewide. This is a map showing you how the symbology is on flood tool right now. We'll do it scale dependent. I just wanted to show you that it got completed for the whole state. So buildings in floodplain in West Virginia, we estimate right now there are 98,940. So almost 99,000 structures which are in floodplain. It will change a little bit, but not much. So in regulatory flood zones, we estimate around 72% of the structures are in regulatory flood zone. So out of 98,000, we estimate that around 13,000, they will get mapped in whenever the new flood study gets done in different regions in whole state. At the end of it, around 13% potentially will get mapped in. Around 13,900 structures, there is a potential for them to get mapped out. So this is a first cut, but like if somebody is applying for ELOMA or things like that, or for LOMA, they can, I mean, more detailed analysis can be done and we can show how to do it. There are links available on the flood tool that have been created, how to go and do it. So we will do statewide reports. We will do community level reports also. So this is one quick summary of primary structure that was run for this before the meeting. And what we see here is like region 3 stands out. For region 3, a total of 22,000 structures in the floodplains. And then, the further subdivision of different types of properties. So region 3, then region 2, and region 1. We haven't area weighted it or like as percentage of structures as compared to the total structures. That part still needs to be done. But this is the raw numbers which are coming out right now. So if we go in further detail, this is showing you how many structures are getting mapped in each region or getting mapped out. So if you see here region 3 stands out, around 3,000 structures, they are potential to get mapped out, and around 3,052 in re-study, whenever that happens, they will get mapped in, but bulk of them, they will remain same. So this is one sample of like what now we are moving in this phase, and we are trying to do this study. But all this study that we are doing, and when we finish it, once we get the community feedback, we incorporate and rerun the models. This will go in a community profile dashboards, where we will have all the flood risk information, what Aaron discussed about the landslide risk, all that will be part of that. And the CRS credits for each community, that information will be there. And hopefully that information can be used by each community, and especially if a community is applying for CRS credits, they can use a lot of this information for CRS credits of different activities. And finally, like once these outputs are with each communities, hopefully they can identify mitigation actions based on the different risk in each community. And there are different FEMA grants available, like Bragg grants, things like that. I mean, once the mitigation actions takes place, hopefully that will help build resiliency in this state. So that is my last slide. And this is contact information for us at Tech Center. And if you have any questions.
Thank you, Maneesh. Are there any questions before we just go to a quick break?
Yeah, Manish, the community updating, here. What is it that you're looking for? Because for instance, I have building footprints of every building in the county. Are you looking for like just a shapefile, those footprints with the address, the ones we have with the address points on them that would eliminate our accessory structures?
So when we started the project, we used Microsoft Building Footprint. That was one component of identifying the structures. If you have updated one, that's good. We can incorporate that. But in terms of what we are looking for now at this stage is community feedback in terms of like data outputs that we have generated. So the first thing to verify is we can give the different outputs that we have. So essential facility is one thing that we want to get verified. Then we have minus rated structures. We want to get it verified whether our first floor height is accurate or not. So in that first floor height, we are looking if community has elevation certificates, especially elevation certificate 5 to 8, if they have it. If that can be given to us, we can host it on Flood Tool and incorporate in the models. And then the other outputs, we can talk more detail later on, but all the tabular outputs, they are on FT Tech Center site. So we still need to do region 2 and 3 meeting and to share the outputs for feedback. But rest of the regions we already had meeting, and Kurt has been especially reaching out and going through the outputs, and we have been trying to incorporate whatever feedback we got.
Okay.
Hey, Maneesh, could you make a comment on like how your team or I know your collaboration effort on how you come to resolution on your cartography and your symbols and used in your portal? Because it's pretty impressive.
It's a collaborative. Thanks, Joe. It's a collaborative effort. Eric has been doing a lot of symbology, but we thought like starting with red color. Red means danger, so that's where we started with that, and we tried to. Then we like gradually, and tried to have a different symbol so that it stands out. And any suggestions are welcome that can be improved on Flood Tool. Any other questions?
Let's take just like a 5-minute break. If you wouldn't mind, don't actually leave the session. Stay in the session, but if anyone just wants to, stretch their legs, run to the bathroom, be back here in about 5 minutes, okay? All right. I think we are ready to go ahead and get started. Marvin, are you back yet?
Yes, I'm here.
Cool. All right, you should have co-host and you can begin whenever you're ready.
Okay, let me get that fired up. Is the correct screen showing?
Yeah, looks
Okay.
good.
Hello, everybody. I'm Marvin Davis. I'm the GIS analyst for the city of Morgantown, and I'm presenting on the using GIS tools for balancing city wards. Just as a quick commentary on this presentation, I'm going to basically do a really brief overview of the city elections and the tools involved. I'm not going to do a deep dive because it's a 15-minute presentation. So if you do have any questions, if we have time at the end, I'll be happy to answer them. But I'm also providing a reference to the full report that I drafted earlier this year relating to this project. So if you like a more deep dive into it, I will present you resources to get such deeper dive. So just diving right in, Morgantown's elections are a little unique in that they're every 2 years, and the wards are not so much representative districts, but they are more for the selection of individual councilors. And what I mean by that is the citizens vote for all councilors on city council. They don't just vote for their particular ward. And in doing so, up until this year, they voted for all 7 at once. Starting in 2023, the councilors will have staggered 4-year terms instead of every 2 years to achieve a more consistent city council, because every 2 years there was presenting quite a bit of turnover. And the group that's responsible for reviewing the city wards prior to every election is the Ward and Boundary Commission for the city. And they are composed of registered voters from every ward in the city. And just to give you a little bit of background on what the city's charter states the wards should be, this is a very long, language, so I'm just abbreviating it, but that they shall be conformed of contiguous territory, and that the boundary lines shall follow precinct lines and center lines of streets wherever practicable. The research I found only one of those to be practicable. And that the wards shall contain nearly as practicable the same population based on the most recent American Community Survey, decennial census, and registered voter data from the most recent general election. And for this purpose, I'll dive into that data in a minute. Just to give you a heads up on the prior situation, the wards based on the 2020 American Community Survey estimate showed deviations, and I'm just saying the deviation from the mean, if you evened them out across all 7 wards, we ended up with quite a bit of deviation in population. For the most recent general election, 2018, the registered voter counts for each ward, the deviations were a little bit better, but still wildly off on some of the wards. So the history of this, just as a quick background, previous attempts at this had to be done delicately because of political pressure. This is a political process, so you may anger a certain community within the city, or a particular street that it was in one ward and now they're in another ward. And so there had been quite a bit of struggle preceding this project. So I went into it with on my tippy toes, knowing that I was going to have to be very careful of how this information is presented. So
after talking with the Board and Boundary Commission, some of the goals that were immediate, one was the data had to be balanced across all 7 wards. And so the ideal situation was to balance both the population and registered voter counts as much as possible. And they used a 10% threshold as ideal in deviation. But the question was asked, if we can't get both to balance, which do we prioritize? And they prioritize registered voters because the process to select a counselor requires petition signatures of registered voters. And that was the explanation provided by the Ward and Boundary Commission. The second goal was to preserve the existing neighborhood boundaries as much as possible. That presented a problem, which I'll touch on, but I'll go into a lot more detail in the full report. And then to also utilize physical boundaries and ensure contiguity by preserving the street connections. And so some easy boundaries such as streams, where street connections don't exist, we had to preserve contiguity as much as possible. Just a brief overview. I'm not going to touch on all of them, but some of the tools I used ArcGIS Pro and the business analyst extension provided by Esri. The specific tool within business analyst was territory design that I utilized for this project. And then also we utilized Survey 123 and story maps for the later portions of the project. And just to touch on again, data-wise, American Community Survey estimate from 2020, 2018 Montague County registered voter counts. We utilized a mix of the 2010 census block polygons and the 2019 Montague County tax parcels. And the only reason that we merged those two together was to have a segmented city of Morgantown that did not leave out areas such as street rights of way or anything of that sort, because the question would be regarding the data enrichment tools that are in ArcGIS. So the first couple of runs for territory design presented some questionable maps, to say the least, in that it created territories, but it did not have any sense of making everything contiguous. So what it was doing was assigning territories based on the parameters, which were the population and the registered voter counts. And it was proving quickly that we could not balance both and have a map that made sense. So what we decided to do was what I titled tool assisted manual assignment, which was I produced a raw output with particular parameters, and then I cleaned up the territories where certain blocks were put in the wrong territory and putting them in the correct territory. And in doing so, I was able to pretty much check on the fly where my deviations stood. And the deviations on the first run, you can tell population still had quite a bit of deviations, but the registered voters automatically had a sub 5% deviation. So I ran it again, did another run. Population deviations still were quite high, but registered voter deviations evened out a little bit, but we ended up with one that kind of stood out above 6% there. A third run, once again, population struggled to get something that resembled a small deviation, but registered voters were all sub 5% again. After the third run, this was all presented to the Ward and Boundary Commission, and they asked to have another run performed, which is what you see in front of you, with the fourth and final run, which was chosen by the Ward and Boundary Commission as the starting point for the next step, which was to refine the boundaries based on whether or not it followed a neighborhood boundary or it was not contiguous based on their goals. But as you can see, the deviation wise was a lot better on both categories. And I'll show in a minute, we actually were able to improve upon that a little bit. Another portion of this project, which was kind of done on the fly, was the Ward and Boundary Commission requested public comment and public input on the proposed boundaries, which was the run you just saw before you. And they asked to just have a quick survey for public input to be published, and I did that utilizing Survey 123, and that took a matter of minutes to have the survey done, published, a link provided, and distributed to neighborhood commissions and also the general public through the city's social media. And we got quite a bit of responses. A lot dealt with things that weren't necessarily tied to our project, but I'll digress. So after all the public comment was integrated into this project, we did a few adjustments during one of the meetings, and we actually ended up with a final product where all the deviations for population were under 30% finally, and that the deviations for registered voters were all well under 5%. And so just to get into the results, business analysts did prove useful for this project. One of the questions was, territory design is not meant for this purpose, but the question was, could it be? And I thought so. And I believe that it actually was a huge help in providing an objective, apolitical analysis of geography that we were able to provide a useful objective map that did not, or that had all the data to back it up. And even though we could not balance the criteria, if you notice, the max deviations for both were substantially reduced from the prior ward boundaries to the approved ward boundaries. And from the general public to the Ward and Boundary Commission officials to City Council itself, was a highly positive reaction to the entire process of this, because this was the first time GIS had been utilized in such a fashion to provide a very granular analysis of the city wards. Future analyses, some of the ideas are if such a thing such as automatic voter registration were implemented, where as soon as you turn 18, get a driver's license, you're automatically registered. What would that do to the ward boundaries? I don't think we're necessarily worrying about that right now, but that was one of the options, looking at like age groups, everybody above 18. How does that change the population and the balance in the wards? But ideally, right now, the idea is in 2022, we will do this process again, utilizing the 2020 decennial census, and hopefully have a more refined analysis that's not based on population estimates. And so I think I'm almost out of time here, but I'll open the floor for any questions or comments. If you want to read the full report, I have the link provided here. And if you don't have time to write the link down, if you just go to the City of Morgantown website at morgantownwv.gov, just go to the search bar and type in Ward and Boundary Commission, and it will take you to the page where it has the link posted to this story map final report. Thank you.
Thank you, Marvin. Yeah, we've got about another minute or so left if anyone has a question. Okay, then we can go ahead and move on to Joe's presentation.
Okay, got to remember to unmute. So let me share my screen. And I have my Presentation ready to go. So I recognize a lot of people's names, but for those of you who don't know me, my name is Joe Trimboli, and I work for the U.S. Army Corps of Engineers here in Huntington. I work in the planning branch, and I'm a community planner. But my community planner at the Corps is basically a multidisciplinary field or job description. So we have a lot of different kinds of degrees in our office, but I'm the only geographer. So I've been wanting to do that. I've been wanting to do this for a long time, but sometimes in the past, I've worn multiple hats, and but now I'm focusing a lot on GIS and trying to integrate it in our planning activities here at the Corps. Most of the time, the Corps is known for our engineers, and but in the future, I think a lot's going to be done with data sharing and services and things. And the Corps is just now starting to implement those activities, and basically look forward to it and look forward to being a part of it. So just to comment on the title here, when the presentation, when the email came through that we was having the conference, I was pretty busy, still pretty busy on doing a current study. So basically, I just wanted to share what I'm doing now. And if I do it right, I'll be doing like Matt was saying in the beginning, just telling the story. And of course, I wanted my story to be a little different, so I used QGIS, as an example here. But we're actually as far as our enterprise GIS system, we're an Esri shop, just like most are. I'm also a part of the GIS SME cadre for the Corps, which deploys in support of FEMA, and have and do deploy a lot. Part of a team rotational concept in the Corps that does that, and I'm the leader of the red team, which rotates on a monthly basis. So we get to look forward to hurricane season pretty soon. But the project I'm actually working on is in Ohio, but we've done these types of projects in West Virginia also. We just call them watershed studies. We have a lot of different authorities where we can assist and have opportunities to participate with our states. And this FPMS program is one of those. We also have a few others that lets us work for the state. But most of the time, it's us being invited to. And one of our planning initiatives, we work under authorities, and much like a lot of other federal agencies. But one of our directives is to share our, technical capabilities in this arena, in this field of flood risk management. Kind of like the things that Maneesh talked about. Within our civil works boundaries. But not only that, we have a Silver Jackets program boundary, and those are generally state by state. So our district states are Ohio and West Virginia. So this project is a watershed study up in the northeast part of the state. And so it's on the Tuscarawas River and the Chippewa Creek. A lot of our projects get created and initiated outside of our agencies and, like the states, and interest from our congressional representatives. One of the things we do on a yearly basis is coordinate and give briefings of these types of activities to our congressional representatives. So this isn't any different. So what I'm doing in a watershed study, I'm basically a consumer of everybody's data, FEMA's, the states, USGS, Homeland Security, a lot of different resources, because we do what we call an inventory of the watershed. And basically it's, reported on, it's very similar to what a lot of different agencies do, you know, in the same types of studies. But I have noticed a change in those things occurring. Ohio was a good example because, you know, there's a lot more science going on in the watersheds and a lot more GIS activity. You know, it's creating a different and interesting dynamic that exists, you know, in this field. So I'm pretty interested in that. So when I look for resources, you know, I start out Googling GIS REST services. And it's amazing what you find because I want to go right for the data sources that's available. And so this is examples of those. Some of the examples from these are basically like figure drawings that will be included in the report. And this is our big, I mean, and this started a long time ago when we, you know, our generals created the concept and was integrating our organization into these activities. So, and it, like the Army does everything. I joke about this, but it's like an 8th grade level. I say that too because I was in the military for a long time also, but their communication is very direct, you know, very concise. So when we're doing this, we're looking for problems, issues, and opportunities, and that's what we're documenting. But in this case, we're using the GIS to facilitate that. The NFIP data is obviously one of the main sources that we use in looking at the risk, you know, for the watersheds and identifying hazards. So what I'm doing on here is also working with a hydrologist who is going to be updating the hydrology for these counties. So initially, you know, besides pulling together the existing data, we're going to be recreating we're going to be creating new data and doing a new model. So initially, that research also leads me to the FEMA engineering library. And this is that site. So there's this top one is actually the Map Service Center. That's kind of where you find, you know, the general maps for the program, the NFIP program. But this mapping information platform has taken the place of the engineering library that we used to, you know, fax a request in for the more information that we need to do these types of hydrology studies. And so I've done that for, you know, a number of times in the past, and we always end up coordinating with the actual FEMA office, mainly because our studies are so big. You know, this is, you know, it's not typical to do a 5-county study. It's, you know, and the process always requires, you know, reviewing the existing data, especially if you're going to remap it. You always have to do that type of research. So this is actually a team effort, you know, in our office between myself and the hydrologist who's been assigned for the project. And this is what the engineering library has looked like for a long time. And it is currently, this is a current, you know, screen capture too. So in this example, I'm querying a county in our project area for the study information. So I want to show you this because I thought it was going to be easy, but let me show you. See where it says the type of data product? You know, this is just looking at one county. Oh, I'm going to find some hydraulic studies. Well, here is what that list looks like. I've kind of done a, you know, trick with the graphics here and captured the whole pull down list. So you can see that. So these are all the different types of FEMA studies that are in the engineering library. So it was like, wow, it was like overwhelming. So we, you know, worked with it for a long time and tried to figure out what we needed. But then eventually I ended up contacting the FEMA region. In this case, it's Region 5 up here. I guess they call it Chicago. Or no, that's just the city there. But Region 5. And they were very helpful. You know, during our discussions, because we had already tried doing a lot of the standard processes, but, you know, we didn't get very good responses from the map service center. And I'm not trying to be negative on that, because you know, trying to order a 5-county area is not typical. But I always try the process, because that's, you know, that's what's presented to you as, you know, the way to go and the way to request that data. But in this case, when we were talking with, you know, the mitigation chief for the FEMA Region 5, she says, "Oh, we got this new tool." And, you know, she just referenced it to me as the CNMS map viewer. So, man, that's when I started getting excited about it, because, you know, their portal here shows a lot of information for their studies. So I started researching it a little bit more. And so it's a whole effort. You know, they have a whole documented strategy of this. And so what interests me about this too, and one of the reasons why I chose to present it, is because I think that a lot of our agencies and federal agencies are going through this process where they want to do this. And I know, you know, we're in that same boat too. You know, we will be wanting to do this same type of coordinated needs management with our state partners. So that's one of the reasons why I wanted to bring this up, because it's how to integrate these GIS activities into that process, how to make things more efficient, and what we call it in the core is how do we operationalize our planning. And here they're doing it. Here's FEMA's doing it. So it's like, oh man, this is pretty cool. Not only that, but they got a whole document on it. I definitely recommend that for some reading. Highlighted some of the more interesting things on there that I thought, you know, as a flood risk manager. So they show areas that need revised. I thought, wow, man, that's pretty nice. It's going to fit right into, you know, our reporting activities and our efforts. And here, I really like this because it summarized their initiative here. Initiative to update the way FEMA organizes, stores, and analyzes flood hazard mapping needs information for communities. You know, because you know, you don't see it, but I'm telling you the story. Like, we coordinate a lot with the West Virginia GIS Technical Center, and are currently doing so. And so this is an example of that. This is, you know, the same thing. How do we coordinate that? Organizations, how do we do the mutual floodplain analytics, you know, to facilitate all of our activities, all of our mission areas. So I was pretty excited about this. I haven't had a chance to dive into it that much, but I definitely plan to. And then I started finding these other links that it was like, man, I know that's the same data. You know, it's obviously, as GIS professionals, you know, all that same data drives different portal areas and different, you know, depictions of the data. So then I found this link on the hazard portal. And the one thing I liked about it is I was able to find the rest service. I told you I do, you know, I go right for the rest service if I'm looking for anything. And sometimes it's easy to find like this, you know, and sometimes it's not. You know, it just depends on how it's programmed, I guess, what server software you use and how it's presented to the public. But yeah, CNMS and additional study data. So this is the study tracker, and this is the CNMS viewer. So I mentioned that we use, I have 3 softwares on my computer, the Pro, MAP, and QGIS. I use them as I need them. They all have their benefits to me and as far as these processes. So when I was doing that, and I found this happens a lot, even on my deployment, is sometimes it's not as easy to download information in ArcMAP as it is in QGIS. So that's what I wanted to show here. I think initially in the, when they asked me for a title, it sounded like it was a comparison, but it wasn't. It's not really a comparison. I use QGIS as just another toolbox. And one of the cool things, I want to show this to you. QGIS started with the Corps of Engineers, so I didn't really know that I was utilizing it, as part of our history. So that was pretty cool. And let me show you that how it's integrated. This, this is a project map here, but they have different libraries. Of course, they're all open source libraries, but GRASS is included in there. And I've used them tools enough to recognize them as like, heck, I started using the Esri product at, I think, version 3.2 of ArcGIS. And these tools look just like those, the raster vector tools. So it's pretty cool. So here's what I ended up doing. So here's our study area boundary, and here's our QGIS project file. And, it's very similar to, I use CAD programs a lot in the past. My master's degree in geography was in 2007, so it's not too far away. It wasn't that old. We had GIS. We were doing the raster analysis and vector analysis already, so it's not that old. What's really come on is, Esri's ability to publish the geography using the web tools, the HTML type code and Java code and all the other ones, Python. So, this is no different. It has a data source manager. You create links. This example here that's already on there, where I'm going to click new, I link to the university's data all the time. But I'm going to create a new link here to download that CNMS data. So, it's not that different. You plug this REST server information in, give it a name. One of the things I did here, besides before I hit connect, was I just wanted to request the overlapping current extent, because that becomes, the only area that I'm downloading or want to view. And here's that data, and, I just loaded it into the extent. It makes it load a lot easier and faster. And I'm pretty sure that capability is in the Esri product too. Here we're doing an intersect, and all I wanted to do was get the data for the boundary area. Here I'm exporting it to just exporting the selected features. But here's where it gets really interesting. But it has and this was like gold to our hydrologists, because it has all the model information in there. If you actually view this whole table, you can kind of assume that a lot of those fields were calculated fields, because I'm guessing this is a service that, that probably runs on a schedule that, is updated, relatively often because of, what it's supporting and, how it integrates into the hazard library. But this was pretty great to see. Now, one of the things that let us do too, between me and the hydrologist, is identify the data gaps, very quickly, because we started out thinking we're going to do a full-blown model for this area, and a lot of what I'm talking about here is hydrologist terminology, but the hydraulic modeling can get very complex, and this particular watershed has a lot of dams in it too. So he was wanting to get all those flows, he was wanting to do what we always do with our hydrology, is a complete, high quality model for those. And what we found out is there's probably areas that we're going to be missing data. We found that out because of this particular service that's out there. And here's what excited me, because I was helping the geographer get this data, was, man, we could go out, use this reference number and go out there and download it by case number. And, I'm pretty sure, just looking at that document for this product that FEMA is producing, and it's generally produced by one of their large engineering contractors, like, that gets 5-year reoccurring, bids to be in that position. But they're very good at moving forward with this technology. And I'm assuming that this will be better. And I say that because it's their past history. A lot of our federal agencies have this history. FEMA is one of them. I work a lot with USGS. There's all kinds of content out there from a lot of these agencies. And like I said, I'm looking at it as a consumer of that data a lot of times. But this was exciting. Oh yeah, you can go right to it, and you can already know a lot of the metadata, based on that portal. So this is the studies that came up under that particular contract. So we went right to that data after the initial efforts to retrieve it failed. Here we went right to it. I think it's a very good example of, how we want to, as GIS professionals, how we want this to facilitate, our processes. So that's all I have. Does anybody have any questions?
Thanks,
come on, that's it. That's some hard floodplain management questions.
Yeah, if we have any questions at all, we've got just a couple minutes. And if not, that's fine, and we can go ahead and move on. I didn't see anything in the chat.
So if you need to get or want to get in contact with us for any types of floodplain management issues or studies or questions, feel free to get a hold of us. This is the program I run here, Floodplain Management Services. And Michelle Brown, she's new to our office, but very valuable in our Silver Jackets outreach, where we reach out and coordinate with all our agencies, all state agencies. So feel free to contact us.
Great. Thank you so much. All right. So last but not least for this evening is going to be Tyler Bragg for our last presentation for the day. Joe, if you wouldn't mind ending your screen share. There you go. And Tyler, you are good to go.
Okay, can you hear me okay?
Yeah.
All right, great. Okay, let's see. Okay, can you see my screen there with the title?
Yes. And you actually are just a bit quiet. I don't know if it's just for me or if it's for everybody.
Let me check something here real quick.
Okay. It's not too bad. I just Thought I'd let you know if you were asking.
Okay, is that any better?
Yeah, that's perfect.
Okay, great. The switch mics there. Okay.
Glad you knew how to do that because I would not have known.
All right. Okay, so let me move this thing out of my way. Okay, so I'm Tyler Bragg, GIS coordinator with the City of Oak Hill. Thank you for the time here in presenting this little bit of what we're doing here. We've got a lot of different things going on here in the City of Oak Hill. This is one of them that I've found to be particularly interesting and of very good practical use for us conducting asset inspections. And so I just wanted to show the kind of the workflow that we set up and some of the applications that we use to build this. And yeah, so let me just jump right in here. So, you know, what do we call an asset? You know, an asset is it can be any item that you can call it anything you want, but it's anything that is going to require some sort of a routine inspection or, you know, something that is part of your organization that you need to go check frequently. Could be a manhole, could be some sort of a pole or a sign or you know, pumps, valves. We're using this for our sanitary board. And these are our lift stations that pump sewer from a low spot up to some other area of the system. We've got 21 lift stations that we inspect usually twice a week. And so previously they were using just paper inspections for this. You know, the guy would carry around the inspector. He would carry around a clipboard with his paper and go to each one and mark off the necessary things that he needed to inspect. And so it worked out perfect for being able to move this over into the digital environment, utilize GIS for it. It's a standardized workflow. He does the same thing every time to every station. So that standardized format really makes it a lot nicer to pull into the GIS here. So it's important with our particular workflow, the way we've got this set up, the inspector's not collecting any spatial data with this. We're going to be using Survey 123 for the actual collection process. So he's not going to be collecting the points. We've already got points that represent the location of these lift stations, and we've got all the associated information. We just need to compile inspections for that. So that's what we're doing with this. It's more of a form-centric data collection, which is perfect for Survey 123. So let me go. This picture that you see here is one of our larger lift stations that we've got. There's a lot of parts in there that he's looking at. And then the next picture here is one of our smaller lift stations, which you can see there's not really much to it. But the same inspection form is going to apply for the largest to the smallest. He looks at the same things. Some questions or fields may not apply to certain lift stations, but he's looking at the same things on every one he goes to. So here is just an overview. I just got some dots on the map here that show our different lift stations. One of the neat things about this map is I pulled up the legend here, and it looks pretty mundane, but you've got the inspections, green showing that it's a current inspection, orange would indicate that it's excuse me, that it's the inspection's upcoming, it needs to be done soon. And then of course, red would indicate that it's due or potentially overdue. And so we set that up based on an interval of our choosing. I think it stays green for 3 days because we inspect these twice a week. So it'll stay green for 3 days, and then it will automatically, this map is set up to symbolize this using an arcade script. And so it looks at the date of the last inspection, and we said, hey, if it's less than 3 days old, it's good, call it green. If it goes from 3 days old to 6 days old, we're gonna color it orange, and then anything over 7 days old, it's going to be red. So you can see this is actually the live map. This is the live map showing our actual lift stations and their status. And so if I click on one, Don't have a lot of information here. That's intentional. The primary thing in bold is the last inspection date. So you can see that one was yesterday. I think this one here was actually done today. Several of these were done today. So as it looks on our map right now, they're all green. And that's sort of tied into our management side of things for our administrator to look at. And I'll show you that here in a few minutes when I get to the dashboard. So let me scroll down. So I think it's important to note that when you're setting up these inspections like this, it's important to notate, I'm not going to go into the detail of how this is all set up. I've actually got a YouTube video on our YouTube channel that some of you may have seen it already, but it goes into a lot more detail if you were wanting to set something like this up in your organization. But the way this is set up is you got to set up related tables. And again, in that video, I kind of walked through that. And I'll tell you towards the end of this presentation where you can find that video. But all of your inspections are going into a related table. I don't want to override a previous inspection. I want to maintain all of the previous inspection data every time we do one so that we have some historical documentation of all of our inspections. So here, is just the table for our asset feature layer, in this case, our lift stations. And you can see I've got several of them listed here, but this one called Fayette Square comes over to the actual related table where you can see that there's multiple entries. These represent an inspection. Each one of these rows represents an individual inspection. So we didn't want to overwrite the data. So the best way to do that is just to keep this related table. You got to go in and set up all your relationship classes. And again, I go into that in that video. I'm not gonna get into that here. But that's kind of the main structure of the way this is set up. You've got to set up related tables. We use this whole workflow uses a lot of different apps. So it's kind of got a lot of moving parts. So, the basis for this, everything we're doing is stored in ArcGIS Online. We don't have Enterprise. So everything we're doing is in online. We also use Integromat, which I haven't seen a whole lot of mention or heard a whole lot of mention of that so far. I think Division of Forestry mentioned using it some. I'm sure there's some others of you out there that are using it. I don't know how many or to what extent, but if you haven't looked into it, Integromat seems to be a really good automation platform. Esri's got some tools built into that, and I'll get into that here in just a little bit further in the presentation. But it's really great for, doing simple things like sending an email or a text notification, all the way up to actually going in and accessing a feature layer at the REST endpoint, going in and making edits, adding different things to the layer. So it's pretty powerful. There's a lot of things you can do with it. So that's kind of our automation platform. Naturally, in this case, it starts in ArcGIS Pro, setting up your relationship classes and getting that information published to ArcGIS Online. Field maps is what we have to start out initially in the hands of our field inspector. We use a little tool called Cloud Convert. That's in the Integromat scenario. I'll go into that. It's just basically a cloud service that converts from one file format to another. Survey 123, which is where they're actually filling out the inspection data. We've got Microsoft Office for use with feature reports. And I'll talk about that in just a minute. We've got an operations dashboard set up for our administrator to kind of check over the inspector and check on the inspections to see how the lift stations are doing. And then Microsoft 365, where we host a shared Excel file, which is also part of the automated process in Integromat. All of the information for these inspections, not only does it get uploaded into the GIS when the inspector submits the survey, it's also uploaded. Every survey or every inspection that he does gets added to an Excel, actually a couple of different Excel files that we have hosted in the cloud. It adds a little bit of redundancy, and it gives you a little different way to go in and review the inspections if you need to. So next, I've got a little video clip. I didn't want to try to go through switching from my computer to my phone during this presentation. So I pre-recorded a little video clip of the actual inspection process on the mobile device. So let me see if I can get this going. And I'm going to slow this down a little bit and sort of narrate as we go through here. So the process starts in field maps, and this is the same map that we just looked at just a little bit ago in the presentation. It's real simple. We don't need a lot of information on this map. It's just showing the individual lift stations, and then it's going to give us a link. It's the same pop-up as I clicked before. So when you click on that point, it's going to bring a pop-up, and I'll explain what we see in that pop-up here in just a second. Okay, so here we go. Oh gosh, that's going to be right in the way. Let me see if I can talk through this. There's a lift station inspection hyperlink there. That's going to be the one that we're going to click. Let me close this out. This lift station inspection hyperlink, that's set up through the web map. That's going to be a link to directly open the survey. Now I've got that set up with some different URL parameters. If you've messed with Survey 123 much, you may have messed with the different URL parameters. But in this case, that's going to open up the survey, and it's going to bring a couple of attribute fields or attributes from the main layer over into this to this inspection, like the name of the station and the station number and a few other odds and ends. We've also got there's a secondary sort of inspection that we do. It's a work log. So aside from the actual inspection of the lift station, if the inspector needs to do some extensive work or a pump replacement or something like that, we track that as well, and that's through the work log entry. So we've set up a similar process. I'm not going to go through that process specifically, but it's the same situation. So he comes to the same map, and if he needs to do an inspection or if he needs to make a work log entry, he can do it both from this same map, and the links take you to two different places. Also, again, you can see real quick there when you click on one when the last inspection date was listed there. And that's also dynamically updated via Integromat. Every time an inspection is done, and I'll show you this, there's a module that goes back in and does an update on the main feature layer and adds the current inspection date back to the main feature layer every time. And that's what controls the color of these, and of course this text here, last inspection date. So when you click that hyperlink, I'm going to speed this up just a little bit. So it's going to, this is set to directly open in the Survey 123 mobile app. Again, that's the URL parameters are set up to do that. So here we've got the station name, city park comes over, the number of pumps. There's a couple of pieces of information that I want to go ahead and pre-populate, and I do that using those URL parameters. But anyway, this is our inspection form. As you scroll down through, there's a lot of information that we collect. There's some drop downs, some real quick data entry points here, like the clock reading. There are several fields that are, when you click on one, you get certain amount of information. If you click on another option, you get a different set of information. So there's one here like it has a generator. If you click yes, then it asks you a few additional questions. If you click no, those questions go away. So those are all sort of contingent on what answers are put in there. So the inspector is going to go through this quick form. It really only takes a few minutes. Some of them even shorter. It's got the opportunity to input a repair order. If it needs repairs, he can hit yes and input some repair orders. He can attach photos if he needs to, and then simply hit the check mark to submit that, and he's done. That's it. He's done with that inspection. So that's pretty much the mobile part of it. I mean, it's pretty simple. He goes in, takes just a few minutes at each station, fills out his inspection. And then here we've got, I'm going to open this. It's a little easier to interact with in a separate screen here. This is our dashboard that we've got for our manager. As he's sitting in the office, kind of checking up on what's going on, he can pull up this dashboard and get live updates up to the minute. He can quickly look at the map here and, zoom in, see the station numbers show up once you zoom in enough there. But he can quickly get an overview here of when these inspections were done or what the status of each is in regards to needing the inspection just by looking at the color of the dot. So if he jumps on here, sees them all green, he knows they've all been inspected fairly recently. On the right-hand side, we've got a list of all the inspections. And so I can just look, this is in order from the most recent. So the most recent was here, this one called Woodlawn. It was done today. If I click on that inspection, it's going to narrow my results down in the map and in this pane over on the left-hand side of the map, which is the inspection details. So if I'm the manager, I can say, well, I want to see what he did during that inspection. So let me click on that and let me look down through here. Let me check my clock readings. Let me see if he checked generator fuel. Well, this one doesn't have a generator. Did he pull pumps? Did he change oil? No. And so he's got a real quick look right there. And if I want to go to a different one, I just click on down through the list. Okay, so I can just do that. So I can click off of there and they all pop back up again. I also mentioned a few minutes ago that we have the work logs as well. Those are also in this dashboard. So on the right-hand side, I can choose the button down at the bottom here, and I can cycle between my inspection list and, for example, the work log list. So I can look at work logs, and I need to go over to this pane on the left-hand side, and I'm going to switch from my inspection details to my work log details. And so as I click on these, the work logs will come up, and I can see what specific work was performed at any given one of these work logs. So in addition to that, we've also got some category selectors over here on the left-hand side that allows us to filter all this information in the dashboard. If I'm just looking at one particular lift station, for example, I can just select that lift station. It's going to narrow everything I see down to that one particular lift station. So this is a work log. You can see I selected rivers. We've got the list for rivers over here. I can select one of these. I can read what's in the work log. I can see photos if I need to open up and look at photos that were taken. In addition to the photos and what's in this dashboard, we also use, I'm going to open this document. It's a photo in the attachments here, but I'll show you how we get that. This is our work log form. So all the information, when this work log is submitted, our Integromat automation platform automatically takes that information and puts it in a form that we set up using the feature report function in Survey 123. And you can go in and format that. There's a module in Integromat to generate a feature report. And this gets set up, and this is what ours looks like. In the automation scenario, what I actually do is what I use Cloud Convert for. This is a Word document. When it gets created, I use that Cloud Convert to convert it over to a JPEG and then automatically add it back in as a photo to this particular feature. So that's why we see it here in this list of photos that's attached to this feature, because our Integromat automation platform in our scenario automatically took it, converted it, and it uploaded it back to this feature layer so we can see it right here in the dashboard. So that's the selectors. We can do a couple other things. We can, there's a few other things, start and end date, and, any stations that were identified in the inspection as needing repairs. We can narrow that down if we need to, and so on. We've also got a separate package wastewater treatment plant. And so there are a few other tabs in here that show that as well. We can look at the inspections for just that package plant. We can look at work logs for that package plant, look at the details, things of that nature. So So this is our dashboard. This is what the city manager may want to look at this. He can pull this up really quickly and kind of follow up on the status, or the actual manager of the lift stations. So it's real quick. You get a lot of information right here in this one spot. Okay. Oh, in addition to that, I don't want to forget this. In addition to that, I'm going to select back on the rivers station here, for example. Behind the map, I've got another tab on here that gives us all of the main lift station information. So this is all the attributes that we've got that are associated with that lift station. How many pumps it's got, the make, model, serial number of those pumps, when they were installed, voltage, amp ratings of all 4 pumps. Any additional notes we've got on here, is there a spare on hand? All that information is also contained right here. So I can look that up for any particular lift station just by using my selector over here on the left-hand side, and I can see all that information. So not only do we have the inspection, the work log information, we've also got the primary lift station attributes showing in here as well. Okay, let me go back here. So that's a pretty decent overview of the dashboard. One other thing that we do, and I think I mentioned this a few minutes ago, every inspection that's done gets uploaded to an Excel spreadsheet. So here's just a screenshot of the spreadsheet. Coming across through here, we've got every attribute that's included in that related table, and it's all mapped to these fields in this Excel spreadsheet. So it gets added in there, and just every time an inspection is created, it adds a new record to this Excel spreadsheet. So it just creates a running list, kind of creates a bit of redundancy. Just a little bit of a different way to look at it, and a little bit of redundancy. So we've got it in 2 places if we need it, or if we need to do a quick snapshot of all the inspections that were done, in a particular time frame. We might just want to run over here to the Excel spreadsheet, grab it, shoot it in the email, or whatever we need to do. I'm not going to open that for live view because I'm getting kind of running short on time here. I do want to open the Integromat scenario. So we've got a lot of scenarios. We've got 29 active scenarios, a lot of things that we're doing automated using Integromat, but this one is our lift station inspections scenario. And I'll just briefly explain. These are, these individual circles here are modules that do certain things. So it starts out listening for the survey via the webhook. And so when it gets notified that there's been a new survey submission, it triggers this entire process. So this module, that's the Microsoft Excel, that's going to upload it to our Excel document. We come over here. So these 3, the blue one here, the HTTP, the JSON, and then the HTTP, these 3 combined, I got to go through a couple of steps to do it, but this goes back and this doesn't update features on the original feature service to update the last inspection date. As I mentioned to you before, every time an inspection is done, the date of that inspection is put back into the main feature layer so that there's a record of when the last inspection was done. And this is how it does it. And so every time there's a new survey submitted, it goes back and it updates the main feature layer with the date of the most recent inspection. So that one's pretty simple. There's not much to that particular one, but it's powerful. Simple, but powerful. I mean, it'd be a pain to have to go back every time to the main feature layer and input your last inspection date. This saves a lot of time and it works really well. So that is—
Tyler, I'm sorry to interrupt. Do you have to go through that? What did you call it? Scenario only because it's not a feature class? Your survey is it's not editing the feature class directly?
Right. It's not editing the feature class. It's editing the related table.
Okay.
So
I got you.
Because it's not editing the main feature class, I can't in that survey, I can't tell it to update that in the main feature layer because I'm only adding to that related table.
Got it. Okay.
So let me see. I wanted to show also, let me go back. I also wanted to run through the work log entry. As I mentioned that, it's kind of a similar process. This one looks like there's a lot more stuff to it. There's really not. It listens for the survey. This is the module that creates that feature report. So we looked at that, this work log here just a few minutes ago. There's actually a pre-built module in Integromat for creating a feature report. So you would do that in the Survey 123 website. You would configure your feature report there, and then you go through the options with this module to get that set up. So it's really neat. So as soon as that survey is submitted, here's some of the information, configuration for setting up that feature report. There's a lot of work on the front end to get the report actually set up to look the way you want it. But once you do, this is real quick to set up. This you can go right through here, and it's super easy to get set up. Okay, so this one watches a survey, creates that feature report that we were looking at right here. This is a module. Sometimes there's a few steps you got to go to get to where you want to be. This module is just actually grabbing that feature report file. And then we do a couple of things. So we jump up here on this leg of the scenario. This is where I use Cloud Convert. So that's going to convert the Microsoft Word document that is the feature report, and it converts it to a JPEG. And then these two HTTP modules actually go back and add it in as another photo into that inspection record. And that's how we see it. That's how we see it over here in the, let me pull it back up here. Let me look back at all stations here. That's how we see it over here in this dashboard. This is actually, this one doesn't have any photos with it. We just got a description. But that's how we see it back in the dashboard because it's been added back into that inspection record. Then the other leg of this simply, we use the share file to Citrix program for just some file sharing, documentation and archive. That's what we use here in our organization. So these modules actually upload a copy of that work log to our pre-designated location in ShareFile. And that way everybody has access to it, and that work log is archived in our ShareFile server. Then it also goes into, we have another Excel file for these work logs. And in fact, there's actually a separate sheet in that Excel document for every single lift station. So that's why there's so many operations here, depending on, and these are all contingent on which lift station is being inspected. So if we're inspecting, for example, P Ridge number 4, it's going to look for that and say, okay, if the station is P Ridge number 4, we're going to upload it. And then we're going to put that information in the P Ridge number 4 sheet of that Excel document. Okay, so that's what that's doing. So again, really powerful, fairly simple. You don't have to be an expert programmer to get this set up, which is nice. I'm not. I consider myself actually a pretty novice programmer. I understand the logic, but when it comes to syntax and, you know, compiling everything into a statement that works, I got to beat my head against the wall a little bit to get it done. So, you know, it's not that bad. Takes a little bit of research to get it set up properly, but once you got it, it's there. So if you haven't looked into Integromat for automated processes, anything that you might think that you need to do from, you know, we've got some that's just as simple as, for example, if you use Workforce, we've got one that whenever a new workforce assignment is created, it simply sends an email to text to our crew leader that lets them know, hey, there's a new workforce assignment. So simple things like that can be set up with this. It's really powerful, very cost effective. I think we've got the basic subscription. I think it costs, I want to say $9 a month. I mean, it's really, and you can do a lot with that subscription. I mean, I've got 29 active scenarios, most of which run daily or multiple times a day. And it's well within that $9 a month subscription level. So So if you haven't got a chance to look into it, I would highly encourage you to do that. It's a really powerful tool. And then kind of here's the overview. I mean, you're doing asset inspection, and the last 3 steps here are all automated. So, you know, your manual labor is, of course, on the front end, getting it set up. But from there on, you've got the field work that gets done. And once the field work gets done, the rest of the process is automated using Integromat, which is really, really nice. As I mentioned before, I've got an in-depth video on this. Again, some of you may have seen it. I think it went out maybe to the listserv earlier this year. But there's an in-depth video. If you just, search our YouTube channel, City of Oak Hill, West Virginia, and I've got it listed as a webinar for doing these asset inspections. So dives a little bit deeper into setting up the related tables, setting up the Integromat scenarios, and just kind of getting the whole thing set up. So it's, probably pretty boring for most people, but if you're if you're trying to get something like this set up, it might be beneficial to you. And I think I hit everything. We may have a minute for questions. I don't know if anybody will have any. Hopefully I covered that okay. If you guys ever have any questions, I mean, feel free to reach out to me, offline from here, or you're welcome to ask any questions here, and I'll do my best with them.
Thanks, Mr. Bragg. Reporting from the farm, huh?
Yep.
Is that yours in the background?
It's not. It's a stock photo. I can't take credit for that. I don't think I have any areas that big that are that flat.
I couldn't tell if it was just a camera angle.
I'm not sure anyone could be sitting out in the heat like that today.
Yeah, there you go.
Well, thank you so much.
It was great.
Thank you. Thank you guys for the time. I appreciate it.
Of course. Well, hey, that concludes our presentations for tonight, everyone. Please make sure that you come back tomorrow for our awesome workshops that we have. We've got one that's ArcGIS Pro, and then we have one that is Next Gen 911. They both start at 9 a.m. So please show up and attend and hear what they have to say. They've been working on the workshops for a while now, so I'm excited to see what they've got planned for us. And then also tomorrow we've got some exhibitor sessions with our sponsors, and then a roundtable in the afternoon with Kevin, and then I believe some members of the surveyors as well. So that's it for tonight, everyone. If you have any questions at all, feel free to shoot us an email, anyone at admin or in the event hub. I'll put my email on the chat just in case anyone has any last minute questions or has any issues in the morning. But other than that, Kevin, do you have any last minute?
No, I'm good to go. It's time to call it a wrap for the day. Everyone, thank you so much for attending, and look forward to seeing you tomorrow morning at 9 a.m. Don't forget, we have exhibitor sessions. Please take advantage of that as well. All right, look forward to seeing everyone tomorrow. Have a good afternoon.
Thanks, everyone. Bye.